The odd loop that we have used so far executed the statements within them if a finite number of times. That means finite means the limited number of times. However, in real life programming, one comes across a situation when it is not known beforehand how many times the statements in loop are to be executed. That means it is an infinite loop, or there are some certain situations when it is not known beforehand how many times the statements in loop are to be executed. Execution of a loop an unknown number of times. First is main, that is compulsory for every program. Now char another, so another is the char. Now int num, so num is an integer. Do, so do is a loop starting. Now printf enter a number, so we are telling user to enter a number. Scanf %d comma and num, that is we are telling compiler to scan a number. Now printf square of %d is %d, num comma num into num. So here we are printing the square of number. Now printf /n in next line want to enter another number yn. Scanf %c and another. That means while another is equal to y. That means we are asking user that do you want to enter another number. That means this loop will be infinite, or it can be repeated unknown number of times. That is why it is called an odd loop or infinite loop. Now in this program the do while loop would keep getting executed till user continues to answer y. The moment he answers n, the loop terminates since the condition another is equal to y fails. So here we are getting that we are repeating that loop infinite number of times. That means we don't know how many times it will be repeated. Odd loop using a for loop. Main char another is equal to y. So here we are using for loop, odd loop using a for loop. That means we are using infinite loop. We are doing infinite loop using for loop. So main then char another is equal to y. That is another is a char which is equal to y. Int num, so num is an integer. For another is equal to y. Printf enter a number. Scanf %d comma and num. Printf square of %d is %d, num comma num into num. Printf n/n want to enter another number yn. Scanf %c and another. So that means here we are using for loop which is infinite. The break statement. We often come across situations where we want to jump out of a loop instantly without waiting to get back to the conditional test. That means we come across situations where we want to jump out of a certain loop. That means we want to disconnect, or we want to come out of that loop without waiting to get back to conditional test. So there are situations, then in those situations this break statement is used. The keyword break allows us to do this when break is encountered. So we can call return one etc. That means it is breaking the keyword break allows us to do this when break is encountered inside any loop. When break is encountered inside any loop means when we write break inside any loop, control automatically passes to first statement after the loop. So the control is automatically passing to first statement in that loop. A break is usually associated with an if, so it comes in if statement a lot. As an example, let us consider the following example. That means we are considering, or we will see an example now. Write a program to determine whether a number is prime or not. A prime number is 1 which is divisible only by 1 or itself. So prime number is divisible only by 1 or itself. All we have to do to test whether a number is prime or not is to divide it successfully by all from 2 to 1 less than itself. So for finding a prime number, we have to divide it successfully by all from 2 to 1 less than itself. If remainder of any of these divisions is 0, the number is not prime number. So we will explain this. So following program implements this logic. So this program is implementing this logic. Main int num comma I. So num and I are integers. Printf enter a number. So we are telling user to enter a number. Scanf %d comma ampersand num. That means and num is, so num is an integer. We are telling compiler to scan that num. Now I is equal to 2. So we are given while I is less than or equal to num minus 1. If num %i is equal to 0. So here we are telling num, if num is equal to 0, printf not a prime number break. So here we are using a break statement. So this program was about prime number, finding prime number, and here we are using a break statement. So after using this break statement, it is again going to previous position. Now now after break we are writing I plus plus, that is incrementing I. Now if I is equal to num, printf prime number. So this was program in which break was used. So break keeps those that statement into previous. So it is breaking the flow. So in program mentioned above, in this program the moment num %i turns out to be 0, so that is num exactly divisible by I, the message not prime number is printed and the control breaks out while loop. So when this num %i turn out to be 0, that is num becomes exactly divisible by I, then message not a prime number is printed and the control breaks out while loop. Now there are two ways the control could have reached outside while loop. So there are two ways in which control could have reached outside while loop. First is it jumped out because the number proved to be not a prime. So it jumped out because number proved to be not a prime, that's why it jumped out. Now B is the loop came to an end because the value of I became equal to num. So value of I became, so these are two reasons in which by which this happened. Now when the loop terminates in second case, it means that there was no number between 2 to num minus 1. So when loop terminates in second case, so that means that there was no number that could exactly divide num, that is num is indeed a prime. If this is true, the program should print out the message prime number. The keyword break breaks the control only from the while in which it is placed. Chapter 4, the case control structure. In real life, we often faced with situations where we are required to make a choice between a number of alternatives rather than rather than only 1 and 2. So we face situations in which we are required to make a choice. rather than 1 and 2. Example, which school to join, or which hotel to visit, or skill harder, which girl boy to marry. So these are complex situations in which we are we have to make choice between a number of alternatives rather than one or two. Now C provides a special control statement that allows us to handle such cases. So C is providing a special control statement that allows us to handle such cases effectively rather than using a series of if statements. So C language has a special control statement. So this comes under case control structure. Decisions using switch. The control statement that allows us to make decision from the number of choices is called switch. So it is a control statement which is allowing to make decision from number of choices, or more correctly a switch case default. So this is a structure of making decisions using switch. So this is a switch structure which is used in C programming. First is switch, then integer expression, then case 1, then do this case 2, do this case 3, and do this default, do this. So this is a basically comes under that there are various comes under the domain that these are various cases. So we have to perform all those cases. So case constant 1, then do this, case constant 2, do this. So basically this is a switch structure, and it is used for making decisions. The integer expression following the keyword switch is any C expression that will yield an integer value. So integer expression the following the keyword switch, that means after what we write after switch is any C expression that yields an integer value. That means it can be any C expression, that means less than x, less than 5, less than 10, value is less than 10 or greater than 10, etc. So this is any statement which yield an integer value. It could be an integer constant like 1, 2 or 3, or an expression that evaluates to an integer. So it can be integer constant, that means 1 to 3 or numbers can be used in that, or it can be an expression that evaluates to an integer, that means it can be expression or numerical expression also. The keyword case is followed by an integer. So the keyword case means case is a keyword which is used in C. So keywords are basically special words, as we know that. So case is a special word called keyword. The keyword case is followed by an integer. So followed by means we write integer after word case, or a character constant. That means followed by an integer or a character constant. That means a character constant is written after case, or an integer is written after case. They do these lines in above form of which represents any valid C statement. So do these lines, that means case 1 do this, that means after case 1 do this means these are lines in above form of which represents any valid C statement. So do this is any valid C statement. So any valid C statement can be P into N into R, that is for divided by 100, that is for simple interest formula. So it is a valid C statement. So do this line is above form of which represents any valid C statement. Now what happens? So how do this switch statements is working? So what happens when we run a program containing switch? So what is really happening when we are running that program which has a switch? First, the integer expression following the keyword switch is evaluated. That means the integer expression which we write after switch, the keyword, that is special word switch, is evaluated. That means it is performed. Now after performing, it will compare, or it has some condition. That expression which we write after switch, it has some conditions. Now after its evaluation, the value it gives is then match. That means the value it is giving is then match one by one against the constant values. That means constant values we are writing in a case structure. So these are constant values. The value it gives is then matched one by one against the constant values. So case constant 1, so it is evaluated against the case constant value. That means case constant 1, then break, then case constant 2, then break. So when a match is found, so after that a match is found. Match is found means the condition is satisfied. That is why match is found. The program executes the statements following that case. That means program is executing the statements following that case means whatever we are writing after that case statement, that is case constant 1 statement, are executed. So case statement are executed, and all subsequent case and default statements as well as, so and there are remaining statements also, then and all subsequent case and default statements as well as, if no match is found with any of case statement as well. So those are those statements which are remaining are not performed because no match is found. So remaining statements are not performed. Now only the statements following the default are executed. That means the satisfied statements are executed. A few statements will show how this control structure works. So we will see how this control structure is working. So this is, we can say, an example of the case structure. So this is a program. By reading, let us try to read this program, and after reading we will understand how this structure is working. So main is compulsory, first line is main, so it is compulsory for every program. Now the parenthesis or bracket is starting, so second line is bracket. Now third line is int I is equal to 2, so I is equal to 2 is an integer, and then semicolon is given. Now switch I. So switch I means condition of I is satisfied, so that is why it is written switch I. Now case 1, that is printf I am in case 1, and slash n is for going into next line. So printf I am in case 1 for case 1. Now case 2, printf I am in case 2. So these are similar. Printf I am in case 2 slash n, so it is going on next line. Now case 3, then default, printf I am in default. So this is program for showing case structure. Now the output of program would be I am in case 2, I am in case 3, I am in default. Now this was a faulty program. The output is definitely not what we expected. So this is not our expected output. We didn't expect the second and third line in above output. So we didn't expect case 2 and case 3 in above output. The program prints case 2 and 3 and default case. Well, yes, we said the switch executes the case where a match is found and all subsequent cases and default as well. So the statement is the switch is executing the case which is case with which match is found and all subsequent cases and default as well. So it is printing all the cases and default as well. So it printed all cases and default also. If you want only the case 2 should execute, so if we want only case 2 to execute, it is up to you to get out of the switch, and then and there, by using a break statement. So we have to use a break statement for only printing case 2. Note that there is no need for a break statement after the default, since control names out of switch anyway. So now this is a new program. This is main. Now int I is equal to 2, switch I, case 1, printf I am in case 1, break, then case 2, printf I am in case 2, then break. So this break is performing the act of pulling that program out at that point. So the after writing this break in between these statements, the output now of the program will be I am in case 2. So this will be new output of program, because we have written break statements. So this is structure for case, that is switch statement. So in first block we are writing start, then we are writing case 1. So if case 1 statement is no, then it goes to case 2. If it is yes, then it goes to statement 1, and then after it fulfills, it goes to stop. So after starting, case 1 is verified. If it is yes, then statement 1 is executed, then it is stop. If no, then case 2 is executed. If it is true, uh, case 2 is verified. If it is true, it is executed. If it is not, then it goes to case 3. Now then this case 3 is executed, then statement 3 is executed. If no, then it goes to case 4, then case 4 is evaluated, then it goes to statement 4, and statement 4 is executed, and finally it is stopped. Now this is a switch structure. First is switch choice. Now case 1, then statement 1 break, case 2 statement 2 break, case 3 statement 3 break, case 4 statement 4. So this is a structure of a whole switch statements. Tips and trap, few pitfalls should be avoided. That means these are tips and traps. That means these are useful points. Point A: the earlier program that used switch may give you wrong impression that you can use only cases arranged in a ascending order 1 2 3. So it is not necessary that case should be in ascending order, that is 1 2 3 and default. You can in fact put the cases in order you please. Here is an example of scrambled case order. So you can arrange these cases in any order you want. First is main. It is compulsory in every program or every statement. So int I is equal to 22. So int I is an integer. Switch I. Now case 1 to 1, printf I am in case 1 to 1 slash n, then break, case 7 I am in case 7 slash n, break, case 22 I am in case 22 slash n, break. Now default, printf I am in default slash n. So the output of this program would be I am in case 22. So this is output of case 22. So tip B or point B, you are also allowed to use char value in case and switch as shown in the following program. Main char C is equal to X, switch C. So here char value is used instead of int value, that is integer value. So switch C. Now case V, I am in case V, break, case A, printf I am in case X. Now break, now default, I am in default. So this is output of program would be, so output of program would be I am in case X. In fact here when we use V, A and X, they are actually replaced by the ASCII values, that is 118, 97 and 120 of these character constants. So these character constants are not understandable by these compilers. They use ASCII values of those characters. So that is how it comes to know that these are characters. Now is switch statement a replacement for if? Yes and no. Yes, because it offers a better way of writing programs as compared to if. So switch is offering a better perspective because it has a case structure, so it looks better than if. So it is yes and no, that means it is and it is not. So it offers a better way of writing programs as compared to if. And no, because in certain situations we are left with no choice but to use if. The disadvantage of switch is that one cannot have a case in a switch which looks like case I is less than is equal to 20. So we cannot use that in case statement or switch statement. So we can use that only in if statement. All that we can have after the case is an int constant or a char constant or an expression that evaluates to one of these constant, that is even a float is not allowed. So there are a lot of disadvantages in this switch statement. We can check the value of any expression in switch. Thus the following switch statement are legal. So switch I plus j into k, switch 23 plus 45% 4 into k, switch a is less than 4 and b is more than 7. So these expressions are legal. Expressions can also be used in cases provided they are constant expressions. Thus case 3 plus 7 is a correct, however case a plus b is incorrect. So there are a lot of problems in case statement or switch statement. So use more if statement is more used as compared to switch statement. Switch versus if else ladder. There are some things that you simply cannot do with a switch. These are a float expression cannot be tested using a switch. So there are certain things which you cannot do with a switch statement. So first is you cannot use float expression. Then b, cases can never have variable expression. For example, it is wrong to say case a plus 3. So this expression is also invalid. Now c, multiple cases cannot use same expressions. Thus the following switch is illegal. So multiple cases cannot use these same expressions. Switch a, case 3, case 1 plus 2. So this switch is illegal. Now a, b and c above may lead you to believe that there are obvious disadvantages. So we think that we are thinking now that it has very disadvantages, or obviously it is disadvantageous to use switch statement, especially since there weren't any such limitations with if else. Then why use a switch at all? For speed, for speed, switch works faster than equivalent if else ladder. So it is used. So why it is used if else is there? So why we are using this switch statement? So it is used for its speed as compared to if else ladder. It works faster. That's why switch is used. A switch with 10 cases would work faster than an equivalent if else ladder. So switch works faster than an if else ladder. Also a switch with 2 cases would work slower than if else ladder. So as compared to if else ladder, switch statement works faster. If if on other hand the conditions in if else were simple and less in number, then if else would work out faster than lookup mechanisms of a switch. So if else works faster than switch. Hence a switch with 2 cases would work slower than an equivalent if else case. So switch statement is faster. So that is why it is used. Now go to keyword. The go to keyword. Avoid go to keyword. They make a C programmer's life miserable. So go to is a special word which is keyword. So we should avoid this keyword. they make a C programmer's lives miserable. There is a seldom a legitimate reason for using GoTo. So there should be a special reason for using GoTo. One of the reasons that program become unreliable, unreadable, and hard to debug. One of the reason is that programs becomes unreliable, unreadable, and hard to debug. And yet many programmers find GoTo seductive, and the program becomes unreliable, unreadable, and hard to debug. But many programmers find GoTo seductive. That means they use this GoTo keyword. In difficult programming situation, it seems so easy to use a GoTo to take the control where you want. However, almost always there is a more elegant way of writing same program using if, for, while, and switch. That means uh, if, for, while, and switch are very useful than GoTo keyword. The big problem with GoTo is that when we do use them, we can never be sure how we got to a certain point in our code. So we should not use GoTo keyword in programming, but some programmers are using it. So we get information on internet about GoTo keyword, but it is without GoTo keyword there is not much we are missing in programming. That means we can neglect that GoTo keyword, but we should know if we want to study about GoTo keyword, or we are interested, we can search on net. But if, else, for, and other statements are sufficient for our coding in C. Chapter 5: Functions and Pointers. Knowingly or unknowingly, we rely on so many people for so many things. So we know that we cannot do everything by alone. That means we rely on various people. For example, for eating food like pizza, we go to a shop and then we buy it. For a gas station, we go to gas station for refueling our vehicles. So there are various people like that pizza delivery boy, or the person who serves you food, or like waiter, or the person who fills your car's fuel tank. These are people which are required in your life, knowingly or unknowingly. So knowingly or unknowingly, we rely on so many people for so many things. Man is an intelligent species, so we are intelligent, but still we cannot perform all its life task all alone. He has to rely on others. That means we think that we are intelligent enough to do everything, but still we require some people in our life to do our tasks, and we cannot do our task all alone. A computer program finds itself in a similar situation. So basically, a computer program is not a person, but it is a kind of mechanism, or what can we say, tool, which is finding itself in a similar situation. It cannot handle all tasks by itself. Instead, it requests other program like entities called functions in C. So it cannot, so this is a metaphor actually, that a program cannot do its task alone, so it asks for his friends. So program is not a human actually, but there are some sub programs called functions or libraries. So by which a program gets its task done. That means these are additional programs which are used for performing different tasks. What is a function? So what is a function is a important question in this discussion. That a function is a self-contained block of statements that perform a coherent task of some kind. So that means that a function is a self-contained block of statements. That means it is a different code which does which does a particular dedicated work. So that is why function is used. A function is a self-contained block of statements that perform a coherent task of some kind. Every C program can be thought of as a collection of these functions. So every C program is a collection of these such functions. As we noted earlier, using a function is something like hiring a person to do specific job for you. That means we go to eat food at a restaurant. So we are temporarily hiring that person, and we are paying that person to serve food to us. So we are temporarily hiring that person, so that means we are appointing a different person to do a specific job for you. So that person is doing a specific job for us. Let us now look at simple C function that operates in much the same way as the mechanic. Actually, we will be looking at two things. So let us look at a simple C function that operates in much the same way. So there are C functions which are operating in the same way as a mechanic does with our bike. Like a mechanic is repairing our bike, so we are hiring a mechanic to repair our bike. So these functions are included in C programming. So this is program in which function is included. So main, which is compulsory in every program. Now message. So message is a function. Now printf, n cry, and you stop the monotony. So message function includes this message that cry and you stop the monotony. Now there is another function which is message printf and smile and world smiles with you. So that means this is another message. So message function has two different messages. Now we will see output, how it is giving output. Output is smile and world smiles with you, cry and stop the monotony. So this is output. So here the first printf statement was printed, and then second printf statement was printed. Here main itself is a function, and through it we are calling the function message. So main itself is a function, and through that main we are calling message. What do we mean when we say that main calls the function message? We mean that the control passes to function message. So we are meaning that control passes to function message. When the message function runs out of statements to execute, the control returns to main. So when message runs out of statements to execute, control returns to main. So that means main is a compulsory function, and message, when message function runs out of statements, that means these when these two statements were printed, and then it returns to main, because these two statements were printed, now it is returning to main. Thus main becomes the calling function, whereas message becomes the called function. So main becomes calling and message becomes called function. If you have grasped the concept of calling a function, you are prepared for a call to more than one function. So if you are grasped the concept of calling a function, you are prepared to call more than one function. So consider this example. So we can call more than one function also. So message was one function, so we can call more than that also. Now main, so this is compulsory in every program. Printf slash n, I am in main. So we are telling user to printf that I am in main. Now Italy, Brazil, Argentina. So Italy, Brazil, Argentina are three functions which we have introduced now. Now we will see how they are working. So first function is Italy, printf n slash n, I am in Italy. Then Brazil, printf slash I am in Brazil. Argentina, printf slash I am in Argentina. So let us see output of this program. So output is, first I am in main, then I am in Italy, I am in Brazil, and I am in Argentina. From this program, a number of conclusions can be drawn. First is, any C program contains at least one function. If a program contains only one function, it must be main. So one function, at least one function is compulsory. So if a program contains only one function, it must be main. Now, if a C program contains more than one function, then one and only one of these functions must be main, because program execution always begins with main. So if a C program contains more than one function, then these functions must be main, because program execution always begins with main. There is no limit on number of functions that might be present in C program. Each function in a program is called in a sequence specified by functions calls in main. So each function in a program is called in a sequence specified by function calls in main. After each function has done its thing, control returns main. When main runs out of the function calls, the program ends. So after each function has done its thing, control returns to main. As we have noted earlier, the program execution always begins with main. So main is a compulsory function, and each C program can have different functions. That means there is no limit on number of functions that can be put in the that can be placed or written in a program. So this is a program for understanding functions. So in this program we will jump from function to function, and finally we will back to come back to first function. So let us understand this program. So first is main, which is a compulsory function. Now printf /n, I am in main. So /n is written because we have to print it in next line. So /n is written for that. I am in main. So we are telling user that we are in main function. Now Italy. So Italy is another function. Now printf. So we are going in Italy now. So Italy function. So printf /n, I am finally back in main. So this we will understand after completion of program. Now Italy. So in Italy we are printing f/n, I am in Italy. So user will uh, receive that message that I am in Italy. Now Brazil, printf/n, I am back in Italy. Then Brazil, printf, I am in Brazil. Now after Brazil we are going into another function, which is Argentina. So after Argentina, printf/n, I am in Argentina. So let us look at output of this program, then again we will study this program. So output of this program is, first is I am in main, then I am in Italy, then I am in Brazil, now I am in Argentina, I am in Italy, and I am finally back in main. So again we are noticing this program. So in first line we know that I am in, so in output we are getting I am in main first. So in main function first we will be printing that I am in main. So printf I am in main. Now we are going to Italy. So Italy function. Now in Italy we are printing f/n, I am in Italy. So we will print that I am in Italy. Now for Brazil. For Brazil we are printing in Brazil. Now similarly for Argentina. Now after Argentina we are finally back in main. Here main calls other functions, which in turn call still other functions. So Here main is calling other functions, so which in turn called still other functions. Trace carefully the way control passes from one function to another. Let us now summarize what we have learned so far. So we will summarize everything. A. C program is a collection of one or more functions. That means C program can have one function or more function. Now B. A function gets called when function name is called by semicolon. So function will get called when function name is called followed by a semicolon. Main bracket, then Argentina. So Argentina is a function. Now see, a function is defined when function name is followed by pair of braces in which one or more statements may be present. For example, so Argentina is a function and statement 1, statement 2 and statement 3 are three statements. So a function is defined when function name is followed by a pair of braces in which one or more statements may be present. D. A function. Any function can be called from any other function. Even main can be called from other functions. For example, so any function can be called from other functions. Even main can be called from other functions. So main, message. Now printf, can't imagine life without C. Now main. So main can be called from that message function. So any function can be called from other function. Even main can be called from other function. E. A function can be called any number of times. For example, main, message, then message, printf and jewel thief. So a function can be called many number of times. A same function can be repeated a lot of times. F. The order in which functions are defined in a program and the order in which they get called need not necessarily be same. So order is needed not necessarily be same. So the order in which the functions are defined in a program and order in which they are getting called is not necessarily same. Main, message 1, message 2, then message 2, printf, but the butter was bitter. Message 1, printf, Mary bought some butter. So the order in which they are written in a program and they are called is not necessarily to be same. Here even though message 1 is getting called before message 2, still message 1 has been defined after message 2. So here order is repeated. Now G, a function can call itself, such process is called recursion. So a function can call itself also, which is called as recursion. Now H, a function can be called from other function, but a function cannot be defined in another function. So it can be called from another function, but it cannot be defined inside another function. Thus following program code would be wrong. Inside Argentina is being defined inside another function, main. So main, so this is a wrong code. That is main, printf slash n, I am in main Argentina, printf slash n, I am in Argentina. So the following program code will be wrong, because this is a wrong code, because since Argentina is being defined into another function, so we have to define Argentina before that bracket. That means uh, above main or before that bracket is starting, here we have to define it. So we cannot define inside that bracket. There are basically two types of functions: library functions, example printf, scanf, etc. So these are library functions. That means they are already written by the compiler, or what we can say, the person or the organization who is forming that software like Turbo C. So they have libraries of printf, scanf, etc. Now there are some user defined function, just like we defined right now, which is Argentina and Brazil, etc. As the name suggests, library functions are nothing but commonly required functions grouped together. So they are nothing but library function, nothing but commonly required functions grouped together and stored in what is called library. So they are stored in library. This library functions, this library of functions is present on disk and is written for us by people who write compilers for us. So it is written on disk, and it is written by us by people who write compilers for us. Why use functions? Why write separate functions at all? So there a question arises that why we want to use these functions. So why write these separate functions at all? Why not squeeze the entire logic into one function main? So we can use one function main, that is we are using in every program. But why we are using different functions? So there must be some reasons for this. So there are two reasons, that are following reasons. Reason A: writing function avoids rewriting the same code over and over. So this is first reason, that writing function will avoid rewriting the same code over and over. Suppose you have a section of code in your program that calculates area of triangle. So suppose we have a section in our code, we want to calculate area of triangle. So suppose we have that. If later in the program you want to calculate the area of a different triangle, so later in the program you are willing to calculate area of a different triangle, you will not like it if you are required to write the same instructions all over again. So you have to write all those instructions again and again. So you will not like it that you are required to write the same instructions all over again. Instead, you would prefer to jump to a section of code. So instead you would prefer to jump to a section of code, that is function. Instead you would prefer to jump to a section of code that calculates area and then jumps back to place from where you left off. So that calculates area, so that section is function. So that calculates area and then jumps back to place where you left off, that means jump back to program. Now this section of code is nothing but a function, so this section is a function. Now reason B: using functions it becomes easier to write programs, keep track of what they are doing. So using function it becomes easier to write programs and keep track of what they are doing. If the operation of a program can be divided into separate activities and each activity placed in a different function, then each could be written and checked more or less independently. So using functions become easier to write programs. So it is easy to write a function rather than writing all our instructions again, and keep track of what they are doing. So keeping track is also difficult. If the operation of a program can be divided into separate activities, that means if operation of a program can be divided into separate activities, that means separate functions, and each activity placed in a different function, then and we would keep that activity in a function, different function, then each could be written and checked more or less independently. So each could be written more independently, and it will separate code also. It will separate code also to modular functions, also make program easier to design and understandable. What is moral of the story? Don't try to cram entire logic in one function. So moral of the story, that means this reason, two reasons they are saying, or what we can say, they are indicating towards that. Moral of story is, don't try to cram entire logic in one function, that is main function. Don't try to cram, that means include the entire logic in one function. It is very bad style of programming. So it is a bad style of programming. Instead, break a program into small units and write functions for each of these isolated subdivisions. So instead, break program into small units, that is small pieces, and write functions for each isolated subdivision. That means isolated subdivisions are functions, and we are breaking that program into small pieces into isolated subdivisions, and thus separating the code and making it easier for programmer to code or understand that code. Passing values between function. The functions that we have used so far haven't been very flexible. We call them and they do what they are designed to do. So until we learned functions, but they were not that much flexible. The mechanism used to convey information to the function is argument. So argument is used for conveying information to a function. You have unknowingly used the arguments. So you have unknowingly used these arguments until now in printf function and scanf functions. So these arguments are also included in printf and scanf functions. The formal string and list of variables used inside parentheses in these functions are argument. So formal strings which are used uh, in these functions are arguments. The arguments are sometimes called as parameters. So these arguments, so these are formal strings uh, and list of variables, formal strings and list of variables which are used in inside parentheses are arguments. Now these arguments are also called as parameters. Consider the following program. In this program main, we receive the values of a, b and c through keyboard, and the output the sum of abc. However, the calculation of sum is done in different functions called calsum. So in this program the sum of a plus b plus c is done, and it is done in a different function called as calsum. So calsum is a function which is used for performing sum of a, b and c, these three integers. So let us discuss about this program. Sending and receiving values between functions. First is main. So this is a compulsory function which is used in every program. Int a comma b comma c comma sum. So a, b, c and sum are integers. Now printf slash n, enter any three numbers. So we are telling user to enter any three numbers. Now scanf %d comma and ampersand a, ampersand b, ampersand c. So we are telling user compiler. Now we are telling compiler to scan these three integers. Now here comes the sum part. That is sum is equal to calsum a comma b comma c. So calsum is a function which we will write after completion of this program. So sum is equal to calsum abc printf slash n. So slash n is used for writing on a different next line. Sum is equal to %d comma sum, and then program is complete. Now calsum is a function which we will write separately. So let us discuss about calsum. Now calsum x comma y comma z int. So this is a function called calsum. Now int x comma y comma z. Now int d is equal to int d, then d is equal to, so int d means d is also an integer. Now d is equal to x plus y plus z semicolon. Now return d. Now that means return to D. Now output. So here we have completed the function part, that is calsum x comma y comma z, int x comma y comma z. Now D is equal to x plus y plus z, return to D. Now output of this program is enter any three numbers 10, 20, 30. So here we are entering three numbers and sum is 60. So here it is basically the function usage of functions. This program is about usage of functions and how this calsum function is used inside the sum part. In previous program we studied about function. So there are number of things to note about function program. So first is A. In this program, from function main, the values of a, comma b, comma and c are passed on to the function calsum. So they are passed to function calsum by making a call to function calsum and mentioning a, comma b and c in the parenthesis. So sum is equal to calsum a, comma b, comma c. So here we are mentioning sum is equal to function calsum. So in this function, in the calsum function, these values get collected in three variables x, y and z. So these values are collected in three variables. That means a is x, b is y and c is z now. So they are being collected in three variables. So calsum x, y, z is int x comma y comma z. So uh, these ABC values are considered by XYZ by compiler. So they are considered as XYZ. Now B, the variables A comma B comma C are called actual arguments. So A, B, C were actual arguments, whereas the variable X, Y and Z are called formal arguments. So X, Y and Z were formal arguments and A, B, C were actual arguments. However, type, order and number of actual and formal arguments must always be same. However, type, order, that means integer or character, then order, that is a, b, c, the x, y, z, that is order, and number of, that means a, b, c were 3 and x, y, z is also 3, that is number of actual and formal arguments must always be same. So it must always be same. Instead of using different variable names x, y and z, we could have used the same variable names a, b and c, but compiler would still treat them as different variables. So we could have used a, b and c again instead of x, y, z, but the problem is that compiler will be still treat them as different variables. So no matter we call them xyz, compiler is going to treat them as xyz, because if we call them as abc also here also in function also, but they are going to be treated different, so why not call them x, y and z? So that is why we could have used the same variable names a, b and c, but compiler would still treat them as different variables since they are in different functions, because a, b and c were in function main, but x, y and z were in function were in calsum, were in function calsum. So x, y, z are in function calsum and ABC is in main. So calsum is a different function, main is a different function. So that's why no matter what we call them, but they will be treated as different by compiler still. That is why we are calling them x, y and z. There are two methods of declaring the formal arguments. The one that we have used in our program is known as Kerrigan or Ricci. or K and R method, that is Kerrigan and Ricci K and R method. So calcium XYZ INT XYZ. So this is one method. Now another method is calcium INT X INT Y INT Z. This method is called ANSI method and is used more commonly. So this method is called ANSI method and is used more commonly. So this is a different method in which calcium INT X INT Y INT Z. So here inside function, inside that bracket, it has written that INT X INT Y INT Z, but in first KNR method, calcium XYZ is written first and then separately we write INT X comma Y comma Z. So these are two methods of it. In the earlier programs, the moment closing braces of the called function was encountered, the control returned to calling function. So in earlier programs, when closing braces of called function was encountered, that means closing braces was placed or written. After that closing braces, the control returned to calling function. So the control return to calling function means the function which we were writing first, that is main, that we were writing main first. So the control return to calling function. No separate return statements was necessary to send back the control. So no return statement was necessary to send back control means no separate return statement were needed because we were using only one function, that was main. So when we were using closing braces of the called function, uh, the control return to calling function, that means we don't have to call that main function again. So that were the case before we are using several or multiple functions. This approach is fine if the called function is not going to return any meaningful value. That means this approach is fine if we are using a single function and the function is not going to return any meaningful value, means it is not going anywhere to the calling function. In above program, however, we want to return the sum of x, y and z. So in above program, that means in this program, we want to return the sum of x, y and z. Therefore it is necessary to use return statement. So in some programs it is necessary to use return statement. So this return statement serves two purposes. Return statement is having few purposes. First is, on executing the return statement, it immediately transfers the control back to calling program. So on executing return statement, that means after calling return statement, it will immediately transfer the control back to calling function, back to calling program, that was main. So this was first purpose. Now second purpose is, it returns the value present in the parenthesis after return to calling program. So it returns value the present in the parenthesis, that means the instructions that were written inside that bracket. So it was returning the value present in parenthesis after return to calling program. So this was second purpose. Now E, there is no restriction on number of return statements that may be present in a function. Also, the return statement need not always be present at end of called function. So there is no restrictions on number of return statements, that means they can be a lot, that means multiple return statements can be there that may be present in a function. Also, the return statement need not always be present at end of called function. First is fun. Now char ch, printf /n, enter any alphabet, scanf %c and ch. So ch is a char, that means character. Fun is a function. Now printf slash n, enter any alphabet. So we are telling user to enter any alphabet. Now scanf %c comma ampersand ch. So %c is a character. So that is why ampersand ch is used. Now if ch is greater than or equal to 65, so this is first comparison. That means is it greater than or equal to 65, and that means here logical operator is used, and ch is less than or equal to 90. So this is second condition. Return ch, that means return to first function. That means return to initial value, or first for from where the function has started, we have to return to that value. Else return ch plus 32. That means character plus 32. That means we are adding 32 to this character. Whenever the control returns from a function, some value is definitely returned. So whenever control returns from a function means the program goes to that function. That means it returns from a function, some value is definitely returned. If a meaningful value is returned, then it should be accepted in a calling program. So it should be accepted in a calling program by equating called function to some variable. For example, sum is equal to calsum a comma b comma c. So we are equating called function to some variable. For example, sum is a variable here and calcium is a called function. So it is returned to that original value. That means sum is equal to output of calcium. So here it is written in program to a variable. So if a value of output of calcium is meaningful value, then it is stored in program. That means it is stored as sum. Now G, all following are valid return statements. So these are few valid return statements. First is return A, now return 23, return 12.34, now return. So in the last statement, a garbage value is returned to calling function since we are not returning any specific value. Note that in this case the parentheses after return are dropped. So in this statement a garbage value is returned to calling function. So it is returned to calling function since we are not returning any specific value. Note that in this case the parentheses after return are always dropped. So that means since we are, so parentheses are required after that return function. If we want that a call function should not return any value, in that case we must mention so by using keyword void. So if we want that a call function should not return any value, in that case we must mention so we are here mentioning that void display. Now printf slash n head n, that means on a next line slash n heads t heads I win, printf slash n tells you lose. So if we want that a call function should not return any value, so we don't want that call function to return any value, in this case we must mention so by using a keyword void. So here we don't want that function to return to any value, so we are mentioning this with void, that is void display. First, a function can return only one value at a time, thus the following statements are invalid. So it can return to only one value at a time. So these statements are invalid. First is return a comma b, now return x comma 12. So these statements are invalid. If the formal argument is changed in the called function, the corresponding change does not take place in calling function. For example, so if formal argument is changed in the call function, the corresponding change does not take place in the calling function. For example, main. Now int a is equal to 30. That means a is an integer and its value is 30. Now fun, that is function a, function for a, printf slash n percent d. So slash n is for next line, percent d is for integer, comma a. So a is an integer. Now bracket close, fun, that is function int b. So b is an integer, so b is a different integer, b is equal to 60. Printf slash n is for next line, percent d, comma b. So printf b. So the output of above program would be 60 and 30. So first it is written as 60 and then it is 30. So if the formal argument is changed in the called function, so if formal argument is changed means formal argument was a, is changed in call function, the corresponding change does not take place in calling function. This means that when values are passed to called function, the values present in actual argument are not physically moved to formal arguments. Just a photocopy of values in actual argument is made into formal arguments. So values are not physically moved. The photocopy of values in actual argument is moved. Calling convention. Calling convention indicates the order in which arguments are passed to a function when function call is encountered. So it is basically an order in which arguments are passed to a function. There are two possibilities here. First, arguments might be passed from left to right. So arguments might be passed from left to right. B is arguments might be passed from right to left. So these are two possibilities, from left to right and then right to left. C language follows the second order. Consider the following function. So C language is following second order. Now consider the following function call. Fun a comma b comma c comma d. In this call, it doesn't matter whether the arguments are passed from left to right or from right to left. However, in some function call, the order of passing arguments become an important consideration. So in in this call, whether is it from left to right or right to left, that doesn't matters. In some function call, the order of passing arguments becomes important, but in some functions it becomes important. For example, int a is equal to 1, printf percent d percent d percent d a comma plus plus a plus plus. It appears that this printf would output 1 2 3. So this however is not the case. Surprisingly, it outputs 3 3 1. This is because C's calling convention is from right to left. So C's calling convention is from right to left. So this is one example in which we have giving a command that int a is equal to 1. So a is equal to 1 and the output is 3 3 1. So a plus plus, that means the the argument or the calling convention, that means arrangement, was from right to left. So that is why output is 331. Now one dicey issue. Consider the following function calls: hash include conio.hex clr scr. Now go to xy 1020 ch is equal to getch a. Here we are calling three standard library functions. Whenever we call the library function, we must write their prototype before making the call. So whenever we are writing library functions, we must write their prototype also before making call. This helps the compiler in checking whether the value being passed and returned as per prototype declaration. But since we don't define the library functions, we may not know the prototypes of library functions. So this helps the compiler to check uh, the values are passed according to prototype declaration. But why multiple files? Because the library functions are divided into different groups and one file is provided for each group. So multiple files are used because the library functions are divided into different groups and one file is provided for each group. For example, prototypes of all input output functions are provided in file stdio.x. So the prototypes are provided in file stdio.x. Prototypes of all mathematical functions are provided in math.x, etc. So the raised to function, that means 2 raised to 3, 4 raised to 4, so that is provided in math.hex library. Advanced features of functions. So there are some advanced features in functions also. A, function declaration and prototype. Then B, calling functions by value or by reference. And C, recursion. So first is function declaration and prototypes. In any C function by default returns an int value. More specifically, whenever a call is made to a function, then the compiler assumes that this function would return a value of type int. So any C function by default return an int value. Whenever a call is made to a function, the compiler assumes that this function would return a value of type int. If we desire that a function should return a value other than int, then it is necessary to explicitly mention so in calling function as well as called function. So if we desire that function should return to a value other than int, that means we want that function to return to a value, then it is necessary to explicitly mention so in calling function. So we have to mention it in calling function. Main float AB, so A and B are float. Now printf /n enter any number. So we are telling user, so we first define that A and B are float. Now we are telling user that enter any number. Now scanf %f comma ampersand A. So we are telling that scan that float as A. Now B is equal to square A. So B is uh, a function which is square. So we'll write that afterwards. Now printf /n square of %f is %f comma A comma B. So we are telling user that square of %f, that is float, is %f comma A comma B. So this is function which is square. Now float x, so x is a float. Now float y, y is equal to x into x. Now return to y. So here are three sample runs of program. Enter any number, that is 3. then square of 3 is 9.000. Call by value and call by reference. By now we are well familiar with how to call functions. But if you observe carefully, whenever we called function and pass something to it, we have always the value of variables to the called function. So we have observed that whenever we called a function and pass something to it, we have always the values of variables to the called function. The examples of call by value are shown below. So sum is equal to calcium A, B, C, F is equal to fact A. So if we were able to do so, it would become a call by reference. What purpose a call by reference serves, we would find out a little later. First, we must equip ourselves with knowledge of how to make a call by reference. So we have to first know that what is call by reference, and we should understand that knowledge of how to make call by reference. This feature of C functions need at least an elementary knowledge of a concept called pointers. So we need a knowledge of concept called pointers. An introduction to pointers, which feature of C do beginners find most difficult to understand. So an introduction to pointer. So we have to understand what pointers are for that. So for understanding call by reference, there is a concept called concept of pointers, so which is important. An introduction to pointers. Which features of C do beginners find most difficult to understand? The answer is easy: pointers. So pointer is a very difficult feature of C. It is C's clever use of pointers that make it the excellent language. It is, for instance, so it is clever use of pointers. That means use of pointers is done in such a efficient way that it is making C an excellent language. When a C programmer says that a certain variable is a pointer, so when a C programmer says that a certain variable is a pointer, it is hard to get a grip on pointer just by listening the programmer's jargon. So that means it is hard to understand. That means it is hard to get a grip on pointers. That means it is hard to understand pointers just by listening to programmer that it is a pointer. That variable is pointer. Pointer notation. Consider the declaration. So how this pointer notation is formed? So consider the declaration int I is equal to 3. So I is equal to 3, that means 3 is an integer which is I. So this declaration tells the C compiler to first a reserve space in memory to hold the integer value. So this declaration is telling C compiler that reserve space in memory to hold the integer value. Now second is B, associate the name I with this memory location, then associating name I with this memory location. And C, store the value 3 at this location. So these are few declarations that C compilers are getting with int I is equal to 3. Now we will see a diagram of it. So there is a I which is integer. So I is location name. Now 3 is value at location, and 65524 is the location number. So these are three factors in it. So we see that the computer has selected memory location 65524 as a place to store value 3. So 65524 is a location to store value 3. The location number 65524 is not a number to be relied upon. So it is difficult to write or understand. 65524 is not a number to be relied upon, because some other time the computer may choose a different location for storing value 3. So because some other time the computer may choose a different location for storing value 3. So it can be 65523, it can be 65534 or 36. So each time a computer may choose a different location for storing value of 3. So it is not a number to be relied upon. The important point is i's address in memory is a number. So important point is i's address in memory is a number. So that is important point. So this is a program for understanding pointers. So main, then int I is equal to 3. So I is an integer which is value of 3. Now printf slash n address of I is equal to percent %u comma ampersand I. So we are telling compiler that address of I is equal to percent %u, that is d comma I. So let us check output of this program. So the output of above program is address of I is equal to 65524 and value of I is 3. So we are getting address of I here. So which is 65524, this is address of I, and value of I is 3, that is integer value. So we are storing this value 3 at memory location 65524. And we are telling compiler to print that memory location at address of I. So this is a simple example of pointer. So this is program in which we get idea about pointers. So first is main. Now int I is equal to 3, printf slash n address of I is equal to percent %u comma ampersand I. Now printf slash n value of I is equal to percent %d comma I. So in this program we get output about address of I, which is 65524, and value of I, that is 3. So this was program explaining pointers. Look at first printf statement carefully. And used in this statement, it sees address of operator. That means ampersand, that is, and is ampersand, which is used in this statement, is sees, that means C language, address of operator. The expression ampersand I returns the address of variable I. So this expression ampersand I is returning address of variable I. That means it is telling us address of I. Hence it is printed out using percent %u, which is a format specifier for printing an unsigned integer. So percent %u is a format specifier for printing an unsigned integer. We have been using the ampersand operator all the time in scanf statement. So in scanf statement we use ampersand operator every time. The other pointer operator available in C is star, called value of address operator. So another operator which is used in C is star. This is called value at address of operator. It gives the stored at particular address value. The value at address operator is also called indirection operator. So value of address operator is called as indirection operator. So this is another program explaining pointers. So main, now int I is equal to 3. Now printf slash n address of I is equal to percent %u comma ampersand I. So address of I is equal to percent %u. That means percent %u is used here, and ampersand I is used for address, showing address. Now printf slash n value of I is equal to percent %d comma I. Now printf slash n value of I is equal to percent %d comma star and I, ampersand I. The output of above program would be, so first output of address of I is equal to 65524. Now value of I is equal to 3 and value of I is equal to 3. So these are outputs of programs. Note that printing the value of star ampersand I is same as printing value of I. The expression ampersand I gives the address of variable I. So this expression, which is ampersand I, is giving address of variable I. This address can be collected in variable I. So this address is getting collected in variable I. This address can be collected in variable by saying j is equal to ampersand I. So this address is collected in a different variable, which is j. So j is equal to ampersand I. But remember that j is not an ordinary variable like any other integer variable. It is a variable that contains the address of other variable, that is I in this case. So j is not any other variable, it is variable that contains the address of other variable, that is I in this case. Since j is a variable, the compiler must provide its space in memory. So since j is a variable, the compiler must provide it space in memory. Once again, the following memory map would illustrate the contents of I and j. So these are two blocks in which we get value of I. So as you can see, i's value is 3. So value that is stored in I is 3 and j's value is i's address. So i's address is 65524. So j's value is i's address. But wait, we can't use j in a program without declaring it. So we cannot use j in a program without declaring it. And since j is a variable that contains address of I, so j is a variable that contains address of I, it is declared as int star j. So j is a variable which is containing address of I, it is declared as int j. So the method to declare the variable containing address of a character, that is I, is int star j. Let us go by meaning of star. It stands for value at address. So star is representing value at address. Thus int star j would mean the value at the address contained in j as an int. So int star j would mean the value at the address contained in j as an int. Here is a program that demonstrates the relationship we have been discussing. So this is an example program. So first is main, which is used in every which is a function which is used in every program. Now int I is equal to 3, that means 3 is an integer which is stored as I. Now int star j, now j is equal to ampersand I, that is j is value of I. Now printf slash n, that is for next line, address of I is equal to %u comma ampersand I. Now printf slash n, address of I, slash n is for next line, address of I is equal to %u comma j. Now printf slash n, address of j is equal to %u comma ampersand j. Printf slash n, value of j is equal to %u comma j. Now printf slash n, value of I is equal to %d comma I. Now printf slash n, value of I is equal to %d comma star ampersand I. Printf slash n, value of I is equal to %d comma star j. So let us see output of this program. So output of the above program would be address of I is equal to 65524. Now address of I is equal to 65524. Now address of J is 65522. Value of J is 65524. Value of I is equal to 3. Value of I is equal to 3. And value of I is equal to 3. So look at these following declarations. So let us explain few declarations. First is int star alpha char star ch floats star s. Here alpha, ch and s are declared as pointer variables. So these are pointer variables, that is variables capable of holding addresses. So these are variables which are capable of holding addresses. Remember that addresses, that is location numbers, are always going to be whole numbers. So location numbers that are addresses are always going to be whole numbers. The declaration float star s does not mean that s is going to contain a floating point value. So this declaration, that is float star s, does not mean that s is going to contain a floating point value. What it means is s is going to contain the address of floating point value. So s is going to contain address of floating point value. Similarly, char star ch means that ch is going to contain address of char value. So char star ch, that means ch is going to hold address of star value. So star is for holding address of that value. Now, or in other words, the value at address stored in ch is going to be char. The concept of pointers can be further extended. Pointer, we know, is a variable that contains address of another variable. So pointer is a variable that is containing address of another variable. These are three boxes. So in first block 3 is written, so which is value of I. Now address of I is 65524. In second box, address of I is stored as variable j, and which of which value is 65524, and address of j is 65522. Now in k, address of j is stored which is 65522, and address of, so value of k is 65522 and address of k is 65520. Observe how the variables j and k have been declared. Int I, comma star j, comma star star k, semicolon. Here I is an ordinary integer. J is a pointer to an integer, often called as an integer pointer. So I is an ordinary integer, j is a pointer to an integer, often called an integer pointer, k is a pointer to an integer pointer. In principle, you would agree that likewise there could exist a pointer to a pointer. So you would agree that likewise there could exist a pointer to pointer to a pointer to a pointer to a pointer. So there is a lot of pointers. So there is no limit on how far can we go on extending this definition. So there is no limit on how far we can go. Like there could exist a pointer to a pointer. So there is no limit on how far this will go. Now back to function call. Having had the first test with pointers, let us now get back to what we had originally set out to learn, the two types of calls. First is call by value and call by reference. Arguments can generally be passed to functions in one or two ways. A. Sending the values of arguments. B. Sending the address of arguments. So in the first method, the value of each of the actual argument in calling function is copied into corresponding formal argument of called function. So value of each actual argument is copied into corresponding formal argument of called function. The following program illustrates the call by value. Main int a is equal to 10, b is equal to 20. Swap v a comma b. Printf slash n, that is for new line, slash n, a is equal to %d, b is equal to %d, comma a comma b. Now swap v. So swap v is a function int x int y. Int t, t is equal to x, x is equal to y, y is equal to t. Printf slash n, x is equal to %d, y is equal to %d, comma x comma y. Now let us check the output of the program. So output of program is x is equal to 20, y is equal to 10, a is equal to 10, b is equal to 20. Note that values of a and b remain unchanged even after exchanging values of x and y. There is a second method called call by reference. So in second method, call by reference, the addresses of actual arguments in calling function are copied into formal arguments. So addresses of actual arguments in calling function are copied into formal arguments of called function. So this is a program which is explaining call by reference method. Main int a is equal to 10, comma b is equal to 20. So a and b are integers. So a is 10 and b is 20. Swap r ampersand a comma ampersand b. So swap r is for swapping the addresses. Now printf slash n, a is equal to %d, b is equal to %d, comma a comma b. So printf on next line a is equal to so print value of a and print value of b. Now swap r int star x int star y. So uh, int star x means address of x and star y means address of y. Now int t, so t is an integer, so we are defining t as an integer. Int t is equal to address of x. Now we are temporarily storing address of x in t. Now slash so star x equal to star y. So address of x is equal to address of y. Now address of y is equal to t. Now the output of, let us check output of above program. So this is output of above program. So it would be a is equal to 20 and b is equal to 10. So this is output of program. Note that this program manages to exchange values of a and b using their addresses stored in x and y. So this program is basically exchanging value of a and b using addresses stored in x and y. Usually in C programming, we make a call by value, but if desired, it can always be achieved through a call by reference. So generally we make call by value, but we can also use call by reference. Using a call by reference intelligently, we can make a function return more than one value at a time, which is not possible ordinarily. So using call by reference, we are able to return more than one value. So this is a program which is representing mixed call of a function. So in first line is main, so which is a function used in every program. Now int radius, so radius is an integer. Now float, area perimeter, so area and perimeter are float. Printf /n, enter the radius of circle, so we are telling user to enter radius of a circle. Now scanf %d comma ampersand radius, so scanf ampersand radius is written because we have to store value of radius of entered quantity as radius, so that is why it is written as ampersand radius. Now area peri, so area peri is a function which we will describe later. Area peri radius comma and area and perimeter. Printf area is equal to %f comma area. Printf /n perimeter is equal to %f comma perimeter. Now bracket parenthesis close. Now area peri, so area peri is a function in which intr comma float star a float star p, so star a is equal to 3.14, so address of a, that is star a, is equal to 3.14 star r star r. Now star p is equal to 2 star 3.14 star r, so which is address of a. Now let us check out output of this program. So enter radius of a circle, that is 5. Now area is 78.50. Now perimeter is equal to 31.40. Here we are making a mixed call, in the sense we are passing the values to of radius. So here we are making a mixed call, we are passing the values of radius but addresses of area and perimeter, and since we are passing the addresses, any change that we make in values stored at addresses contained in variable a and p would make the change effective in main. So we are making values which are stored in, that is why when control returns from function area peri, we are able to output the values of area and perimeter. Thus we have been able to indirectly return two values from a called function, and hence overcome the limitation of the return statement, which can return only one value from a function at a time. So we are using return function indirectly in this program, and hence have overcome the limitation of return statement. So return statement can only uh, return only one value from a function at a time. So we have overcome this limitation in this program. Recursion. In C it is possible for the functions to call themselves. So there are some functions who call themselves. So in C it is possible for function to call themselves. A function is called recursive, that means it is repetitive. A function is called recursive if a statement within the body of a function calls same function. So if a statement within the body of a function calls the same function, sometimes called circular definition. Recursion is thus, so it is called as a circular definition also. Now let us see a simple example of recursion. A factorial of a number is the product of all integers between 1 and that number. So a factorial basically it is a mathematical concept or a mathematical sum in which it is basically product of all integers between 1 and that number. So 0 cannot be that multiplied, because anything multiplied with 0 will be 0. So factorial of a number is product of all integers between 1 and that number. For example, So this is an example of factorial. For example, a factorial is 4 into 4 factorial is 4 into 3 into 2 into 1. So star is written here because in C language multiplication is done by star. So 4 star 3 star 2 star 1. This can also be expressed as 4 factorial is equal to 4 into 3 factorial. When factorial stands for, so this sign stands for factorial. However, before we try to write a recursive function for calculating the factorial, let us take a look at non-recursive function for calculating the factorial value of integer. So this is a non-recursive function, main. So it is used in this is function which is used in every program. Now int a comma fact. So a and fact are integers. Printf /n enter any number. So we are telling user to enter any number. Scanf %d comma ampersand a. So we are telling to store that number as a, and ampersand a is used because store that number integer as a. Now fact is equal to factorial a. So factorial is a function which we will write later. So fact is equal to factorial a. Printf factorial value is equal to %d comma fact. Now bracket is closed. Now factorial function. So factorial int x. So factorial int x, int f is equal to 1 comma I. Now for I is equal to x, I is more than or equal to 1, I minus minus, f is equal to f star I, then return. So this is a function of factorial in which for I is equal to x, I is more than or equal to 1, and I minus minus, f star I. So this is function for factorial. That means function of factorial is completed here. And here is the output. Enter any number 3 and factorial value is equal to 6. Following is the recursive version of function to calculate factorial value. So this is a recursive version program for finding factorial value. So we use normal program, but this is dedicated recursive program. That means we are using dedicated recursive function here. So first line is main, which is a compulsory function. Now a and fact are integers, so int a comma fact. Now printf /n enter any number. So /n is for next line, so enter any number. So we are telling user to enter that number, enter any number. Now scanf in semicolon %d. So %d is used for integers, comma ampersand a. So ampersand a is for reading that data and storing it as a. So that is used for ampersand a. Now fact rec a. So this rec is a function. We will write it later on after completion of this program. Now printf a factorial value is equal to %d. Now factorial value is %d means factorial value is integer. That is why is equal to %d. Now comma fact. So fact is used for fact which we are getting is a variable which was written in previous line. So fact is equal to rec a. So we are showing user that factorial value is fact now. That is percent in place of %d it is written as fact. Now we will see rec function rec. Now rec rec int x. So we can write a here, int a here also, but compiler will understand it as a different variable. That's why x is written. So here we are performing task on a, which was stored earlier, but we are writing here x because compiler is going to still going to recognize it as different variable. Now uh, rec int x. Now int f, if int f, so f is an another integer we are defining, f is another integer. Now if x is equal to 1, so if x is 1, that means this 2 times is equal to operator is used for comparison x with 1. Now return to 1, that means return on previous value, or else f is equal to x star rec x minus 1, or semicolon, and return f. Now let us check output of this program and then we will explain it. Output: enter any number 1 factorial value 1, enter any number 3 factorial value 6. So this was output. Let us understand this recursive factorial function thoroughly. In first run, when the number entered through scanf is 1, let us see what action does rec take. The value of a, that is 1, is copied into x since x turns out to be 1. The condition if x is equal to 1 is satisfied, and hence 1, which indeed is the value of 1 factorial, is returned through return statement. When the number entered through scanf is 2, that is x is equal to 1, test fails, so we reach the statement f is so when the number entered through scanf is 2, so x is not equal to 1, so test is failing, so we reach the statement f is equal to x star rec minus 1, and here is where we meet recursion. So this is a recursive statement starting now, and here is we met recursion. How do we handle the expression x star rec x minus 1? So we multiply x by rec x minus 1. Since the current value of x is 2, it is same as saying that we must calculate the value 2 star rec 1. We know that value returned by rec 1 is 1, so the expression reduces to 2 star 1, or simply 2. Thus the statement x star rec x minus 1 evaluates to 2, which is stored in variable f and is returned to main, where it is duly printed as factorial value 2 is equal to 2. We have seen recursive version of factorial program, so here we will explain how this program is working. So in case the value of a is 5, main would call rec within 5. So if we are taking 5's factorial, then value of a will be 5. Main would call rec with 5 as its actual argument, and rec will send back the computed value. But before sending the computed value, rec calls rec and waits for value to be returned. So first we will enter 5. So first 5 is computed. Now before sending the computed value, rec calls rec and waits for a value to be returned. It is possible for REC that has just been called to call yet another rec. Now rec 5 returns 5 times rec 4. So when we enter a as 5, so rec 5 will return 5 times rec 4, which returns 4 times rec 3. Now which returns 3 times rec 2, which returns 2 times rec 1, which returns 1. Foxed, that means are you confused? Well, that is recursion. For you in simplest graphs, I hope you agree that it's difficult to visualize how the control flows from one function call to another function call. So it is difficult to understand recursion. That means we are here multiplying 5, then 4, then 3 by 2. So here it is difficult to visualize how the control flows from one function call to another function call. Possibly, so we will see a figure now, would make things a bit clearer. Assume that the number entered through scanf is 3. So we have entered uh, 3 and which is recognized by scanf. So this is a figure of recursion from which it will be easy for understanding what recursion is. So uh, so let us visualize what happens when recursive function rec is called. So here first it is uh, written that from main. So from main arrow is pointing towards rec int x. So x is an integer here. So from main we are going to rec, that is recursion. Now inside recursion int f. So f is an integer and x is an integer. So int x is written. If x is equal to 1, return to 1. That means return to 1 means return to f. Else else f is equal to x into multiplied by rec x minus 1 and return to f and return to main. So this was first step. Now if these steps will be repeated. Now visualize number entered as a 3. Assume that number 3 is entered. Go through figure carefully. The first time when the rec is called, from main x collects 3. So in first time x is collecting 3 from here, since x is not equal to 1. So first if 3 is written or 3 is calculated, so 3 is not equal to 1, so it will be performed as else statement. So 3 into recursion of 3 minus 1, that is 2. So 3 is not equal to 1, then if block is skipped, so if statement is skipped and else statement is carried out. Now a new argument will be there, that is 3 minus 1 2. So rec 2, this is a recursive call. Now this is recursive call, since x is still not equal to 1, so rec will be 2. So 2 is not equal to 1. So again it is compared as x is equal to 1, so which is 2. So 2 is not equal to 1, so rec is again called another time. So 2 into, so else statement will be again carried out. F is equal to 2 star rec 2 minus 1, that is 1. So 2 minus 1 is 1. So rec 2 rec 1 will be carried out. Now rec is 1. So rec is 1, that means it will be compared in if block, that is x equal to, so x is 1 now. So if x is equal to 1 means 1 is equal to 1. So x is 1 now. So it will be returned to main. So that is how this recursion function is working. Recursion and stack. There are different ways in which a data can be organized. So there are different ways in which data is organized. For example, if you are to store 5 numbers, then we can store them in five different variables. So if we want to store five different numbers, so we can store them in five different variables. An array, a linked an array, a linked list, a binary tree, etc. All these different ways of organizing the data are known as data structures. So an array is a data structure. Now linked list, a binary tree. So binary tree is a data structure. All these different ways of organizing the data are known as data structures. The compiler uses one such data structure called stack for implementing normal as well as recursive function calls. So the compiler uses one such data structure called stack. So stack is a data structure and it is used for implementing normal as well as recursive function calls. A stack is a last in first out LIFO data structure. So it is like dishes in cafeteria. That means in cafeteria, the dish which is entered last after washing is to be used first. So a stack is a last in first out data structure. This means that the last item to get, often called push operation. So last thing or last item to get stored on stack is often called push operation, is the first one to get out of it. So it gets first out of it, often called as pop operation. Uh, so putting data or putting item in that stack is called push operation, and removing that data is called as pop operation. You can compare this to stack of plates in a cafeteria. The last plate that goes on stack is the first one to get out of it. So this is program of stack operation. So main is a compulsory function in every program. Int a is equal to 5. So a is an integer and its value is 5. Now b is equal to 2. B is an integer, its value is 2. And c is an integer. So c is equal to add ab. So add is a function which we will explain later. Printf sum is equal to %d comma c. So we are we are printing on screen that sum is equal to c. Now add function int I comma int j. So I and j are integers we are defining. Now int sum, so sum is also an integer. Sum is equal to I plus j. So sum is addition of I and j. Now return to sum, that means return at sum. In this program, before transferring the execution control to function fun, the values of parameters a and b are pushed onto stack. Following this, the address of statement printf is pushed on stack and control is transferred to fun. It is so address is pushed on stack. So values of parameter a and b are pushed onto stack. That means uh, value of a and b were told to the program, or that means value of a was 5 and b was 2, that was told before the addition function. So after telling those values 5 and 2, then then the control is transferred to function, that means add. So control is transferred to add. Now it is necessary to, so in add function it has formula for sum, that is I plus j. So it was pushed before telling compiler to add I plus j. So it was a stack operation. In function, that is add, the values of a and b that were pushed on stack are referred to as I and j. In fun, the local variable sum gets pushed on stack. So uh, it was added on stack. Before execution of printf begins, two integers that were earlier pushed on stack are now popped off. So with help of diagram we will explain this. So here with the help of diagram we can explain this. So leftmost figure is an empty stack, so there was no content at all in empty stack. Now when fun call to function is made, that means in case add, so add was our function. So copy of a, copy of b, phi 2, so they were pushed on the stack first. Now before transferring control to function, that means copy of a, copy of b, so at a 5 was there, at b 2 was there. Now address of printf was xxx. So before transferring control to function it was like this. Now here after control reaches the function some address, so I was stored in some location, that is 5, so a and b are now I and j. Now sum is 7, so it is stored in a different address. That means after control reaches function, that is add, value is stored, sum is stored at 7 on a different address. Now while returning control from function, so again 5 and 2 are there, and on returning control from function, so stack is cleared because it is now it is now printed on screen, so we don't have to store it anywhere now. So that is how this function, that is how stack works. With help of diagram we can explain, and it has a simple programs also. Mechanism of stack operation can be understood with help of a program. So if we explain this program, or we come to know how this program is performed, we can easily understand operation of stack. Note that in program, popping of sum and address is done by function fun. That means popping and putting is done by function. So so popping, that means removing, is done by function fun, which was add. So add was function in our program, whereas popping of two integers is done by main. So popping of two integers, that means the sum was 7, so it was popping. So whereas popping of two integers is done by main, when it is done this way it is known as Seidel calling convention, CDEC-L calling convention. This calling convention also decides whether the parameters being passed to the function are pushed on the stack. So this convention is also deciding that whether parameters to the function are pushed on the stack in left right or right to left order. So they are pushed in orders, that means from left to right and from right to left order. The standard calling convention always uses the right to left order. Thus during call to fun, firstly value of b is pushed on the stack. So during call to fun, firstly value of b is pushed on stack, followed by value of a. So value of fun, that was add, was pushed on stack, followed by value of a. The recursive calls are no different, that means rec calls. So in recursive call we use factorial. We can use them for finding factorials. So factorials are basically mathematical sums or functions in which we multiply that number. For example, 4's factorial is 4 into 3 into 2 into 1. So that is a factorial. The recursive calls are no different. Whenever we make a recursive call, the parameters and return address gets pushed on stack. Also note that while writing recursive functions, you must have an if statement somewhere in recursive function to function to force the function to return without recursive call being executed. That means while writing recursive functions, you must have an if statement somewhere. So in recursive call, it includes a if statement also to function the force uh, to function to force the functions to return without recursive call being executed. So if statement is used in every recursive call. If you don't do this and you call the function, you will fall in an indefinite loop and stack will keep on getting filled with parameters and return address each time. So if you don't use this if statement, you will fall in an indefinite loop and stack will keep on getting filled with parameters. And if you are not using if statement in a call, soon stack will become full and you would get a runtime error indicating that stack has become full. This is very common error while writing recursive function. My advice is to use printf statement liberally during we should use printf statement liberally during development of recursive function so that you can watch what is going on and can abort execution if you see that you have made a mistake. So we should use if statement in recursive call. So it is important to do this. Adding functions to library. Most of the times we either use the functions present in standard library, and would it make any sense in doing so? We can add user defined functions to library. It makes sense in doing so as the functions that are to be used in library are first compiled and then added. So functions that are so library is a section in which the codes or programs which are already written by the manufacturer or a specialized programmer or a professional programmer. So they write those codes in a separate section, and we don't have to type these codes again. So for accessing those codes, we define the library. That means we tell compiler to include a specific library. For example, for using power function, that means if we want to use 2 raised to 2, so for using 2 raised to 2 we cannot do in C programming, but we have to use a library function for that, that is math.hex. So math.hex is a library function. So hex is written because it is a hex code file. So that is why h is written here. So include uh, then bracket math.h and then bracket complete. So we are by telling this we are including the math library. So these are libraries which are already written by programmer. For example, include math.hex, include conio.hex, include stdio.hex. So these are library functions. So most of the times we either use functions present in standard library. That means we don't include any of the libraries. And would it make any sense in doing so? That means uh, if we don't use any library, we are writing our codes again and again. That means the codes which are in library, if we are writing these codes in our program again and again, so our program will become lengthy and it will cost us a lot of memory also. So would it make any sense in doing so? We can add user defined functions to library. So user defined functions, that means our special functions also we can create our own library also. It makes sense in doing so, as the functions that are to be used in library are first compiled and then added. So functions which are used in library are first compiled and then added. Let us now see how to add user defined functions to library. So we will come to know that how to add these user defined functions to library. Different compilers provide different utilities to add, delete, modify. So different compilers are using different utilities for adding, delete and modifying functions. For example, Turbo C, C++ compilers provide utility called tlib.exe. So Turbo C and C++ compilers provide tlib.exe, so which is called Turbo Librarian. Let us use this utility to add functions factorial to library. So we are creating a function called factorial and we are adding it to library with Turbo Librarian, that is tlib.exe. So here we are creating a program, or we are adding a function, that is factorial, a factorial function. We are doing so by following these steps. So step A is write the function definition of factorial in some file, say fact.c. So this is a function definition, that means formulas for factorial. So int factorial, int num. So factorial is an integer and number is also an integer. Now int I comma f is equal to 1. So I is an integer, f is also an integer which is equal to 1. Now for loop starts. For I is equal to 1, I is less than or equal to num I plus plus, f is equal to f star I, that is f into I. Now return f. So this was a function, that means this was formula for factorial which was in step A. Compile the fact.c file using alt F9. So we are compiling using alt and F9. A new file called fact.obj would get created containing the compiled code in machine language. So a new file called fact.obj is created containing compiled code in machine language. Now see, add the functions to library by issuing the command c star tlib math dot lib plus c fact.obj. Here math.lib is a library file name, plus is a switch, which means we want to add new functions to library, and c fact.obj is a path of .obj file. Declare the prototype of the factorial function in the header file, say fact.hex. This file should be included while calling the function. So declaring the prototype of factorial function in the header file. So like fact.hex. Now step E, to use the function present inside the library, create a program as shown below. Hash include c fact.hex main int f is equal to factorial phi, printf %d comma f. So using function present inside library, create a program as shown below. Now we have followed until step E. Now compile and execute the program using control F9. So this is for compiling and execution. If we wish, we can delete the existing functions present in library using minus switch. So we can delete also existing function using minus switch. Instead of modifying the existing library, we can create our own library. So instead of modifying existing libraries, we can create our own libraries also. Let us see how to do this. Let us assume that we wish to create a library containing the functions factorial, prime. So if we are wishing to create a library functions factorial, prime and Fibonacci. Here are steps that need to be carried out to create this library. Note that these steps are specific in to Turbo C, C++ compiler and would vary for other compilers. So these are specific to Turbo C++, and for other compilers these are different. A. Define a function factorial, prime and Fibonacci. In a file say myfuncs.c, do not define main in this file. So define a function. Now create a file name, create a file myfuncs.hex and declare the prototypes of factorial, prime and Fibonacci in it as shown below. int factorial int prime int void Fibonacci int. From the options menu, select the menu item application. From the dialog that pops us, select the option library, select OK. D. Compile the program using Alt plus F, Alt F9. This would create a library function called myfuncs.lib. The library now stands created. Now we have to use functions defined in this library. Here how it can be done. A. Create a file, say sample.c, and type following code in it. So here it is a first step to create a file called sample.c and type following code. Hash include my funcs.hex main intf result. So intf and f and result are integers. Now f is equal to factorial 5, result is equal to prime 13, Fibonacci 6, printf /n %d f comma result. Now that the file myfunction.hex should be in same directory as file sample.c. B. Go to project menu and select open project option. On doing so, a dialog box would pop up. Give the name of the project, say sample.prg, and select OK. C. From the project menu, select add item. On doing so, a file dialog will appear. Select the file sample.c and then select add. Also add to the file myfuncs.lib in same manner. Finally select done. Compile and execute program or project using control and F9. So here that is how we are creating our own library functions. So it is not very useful to create our own library functions because most of them are there in market available. So but we can do so if we are interested. Chapter 6, Data Types Revisited. As seen in the first chapter, the primary data types could be of three varieties: char, int and float. So primary data types are of three varieties. So in this chapter we will discuss about them in detail. So there are varieties of char, int and float. It may seem odd to many of C programmers manage with such a tiny set of data types. So it seems odd that with such a tiny data set of data types, many C programmers are managing to code or managing to perform their task. Fact is, the C programmers aren't really deprived. They can derive many data types from these three types. So the fact is, C programmers aren't really deprived. They can derive many data types from these three types. In fact, the number of data types that can be deprived in C is a principal unlimited. So number of data types that can be deprived in C is a principal unlimited. Not only this, the primary data types themselves could be of several types. For example, a char could be an unsigned char or a signed char, or an int could be a short int or long int. So there are there are various data types, like char is like unsigned char, that means one having sign, one that do not have sign, or sign char, that means it has a positive or negative sign. or an int, that could be short int or long int. That means it stores little data, that means several bytes, that is short int. And long int, it means it stores long data, that means longer integers. To fully define a variable, one needs to mention not only its type but also storage class. So for defining a variable fully, one needs to mention not only its type but also its storage class. So we have to define its storage class also. Integers long and short. We had seen earlier that the range of an integer constant depends upon the compiler. So we have seen earlier that range of an integer constant depends upon the compiler. For a 16-bit compiler like Turbo C or Turbo C++, the range is -32768 to +32767, because 0 is also included here. So that is why 32767 is given. For a 32-bit compiler, range would be -2147483648 to +2147483647. So this is a range for 32-bit compiler. Here a 16-bit compiler means that when it compiles a C program, it generates machine language code. So 16-bit compiler means that when it compiles program, so it is generating a 16-bit it is generating a machine language code targeted towards working on a 16-bit microprocessor. So that compiled code is now targeted towards a 16-bit micro processor like Intel 8086 or 8088. So these are famous microcontrollers, that is 8088 and 86. As against this 32-bit compiler like VC++, that is Visual C++, generates machine language code that is targeted towards 32-bit microprocessor like Intel Pentium. So Intel Pentium is a 32-bit microprocessor. So it is code that is targeted towards a 32-bit MUPI, that means microprocessor like Intel Pentium. It would run successfully, but at that time the 32-bit processor would work as if it were a 16-bit processor. So that means it works on different machines also. If this backward compatibility support is not provided, the 16-bit program would not run on it. So backward compatibility support is also important. This is precisely what happens to new Intel Itanium processors. So backward compatibility support is also useful or important. Remember that out of the 4 bytes used to store an integer, the highest bit, 1632 bit, is used to store sign of integer. This bit is 1 if number is negative and 0 if number is positive. So remember that out of the 4 bytes, the highest bit, that is 16 and 32 bit, is used to store sign of integer. C offers a variation of integer data type that provides what are called short and long integer values. So C is providing a variation in integer data types, which is providing short and long values. The intention of providing these variations is to provide integers with different ranges whenever possible. So uh, providing these variations is to provide integers with different ranges. Each compiler can decide appropriate sizes depending on operating systems. So each compiler can decide appropriate sizes and hardware for which it is being written subject to the following rules. Shorts are at least 2 bytes big. Second, longs are at least 4 bytes big. Shorts are never bigger than ints. Ints are never bigger than longs. So this is figure 6.1, in which we are getting knowledge of the 16 and 32-bit version. First is Turbo C or C++, and second 32-bit is Visual C++. Short 2 2, now int 24, long 44. Long variables which hold long integers are declared using keyword long as in long int I, long int abc. So these are used. So long keywords can be used for declaring long integers. Long integers cause the program to run a bit slower, but the range of values that we can use is expanded tremendously. The value of long integer typically can be from this number to this number. That means there is a long range has a long values. That means a long range numbers can be added like 1 lakh, 2 lakh, or so long numbers can be added in this. If there are such things as longs, symmetry requires shorts as well. So uh, so if there are longs, then symmetry requires shorts as well. That means there are also shorts in programming. Integers that need less space in memory. So short int are integers that need less space in memory and thus help speed up program. So they are helping speeding up program execution. Short integers are declared as short int, short int j, short int height. So these are j is an integer, short integer. Similarly, height is also short integer. C allows the abbreviation of short int to short and long int to long. So C is allowing abbreviation of short integer to short and long integer to long. So the declaration made above can be written as long I, long abc, short j, short height. So these are basically examples of short and long. Integers, signed and unsigned. Sometimes we know in advance that the value stored in a given integer value will always be positive. So we know that in certain situations that value is negative or positive. Being used to only count things. For example, in such a case, we can declare the variable to be unsigned, as in unsigned int num students. So we can declare that variable as signed or unsigned. So example is unsigned int number of students. So number of students is int. With such a declaration, the range of permissible integer values for 16-bit OS. So there are 16 and 32-bit and 8-bit OS. So with a declaration, the range of permissible integer value for 16-bit OS will shift from range -32768 to +32767. 32767 is given because 0 is also included here. So it is up to 67. To the range 0 to 65535. So this is new range now. 0 to 65535, thus declaring an integer as unsigned almost double the size of largest possible value. Thus declaring the integer as unsigned almost double the size of largest possible value, otherwise it can take. So declaring as an integer, it doubles the actual size of possible value, otherwise it can take. Note that an unsigned integer will occupies 2 bytes. This is how an unsigned integer can be declared. So unsigned integer I. So I is an unsigned integer. An unsigned I. So like an unsigned integer, there are also exist a short unsigned integer. So it has a range, long and short. So there also exist a short unsigned integer and a long unsigned integer. So long is also there. By default, a short int is a signed short int and a long int is a signed long int. Chars signed and unsigned, parallel to signed and unsigned integers, either short or long. Similarly, there also exist a signed and unsigned chars, both occupying 1 byte each, but having different ranges. So, signed and unsigned chars are also do exist, each having different ranges. To begin with, it might appear strong as to how a char can have a sign. So, it might appear that as how a char can have a sign. Consider this statement: char ch is equal to a. So ch is a char which is equal to a. Here, what gets stored in ch is the binary equivalent of ASCII value a. So binary of 65 is stored in char a, and if 65's binary can also be stored within minus 54's binary can also be stored, and sign char. A sign char is same as ordinary char and has a range from minus 128 to plus 127, whereas an unsigned char has a range from 0 to 255. So these are ranges of these signed char and unsigned char. So this is a basic program. Main char ch is equal to 291. So 291 is a character and it is defined as ch. Now printf slash n, that is on the next line, percent d percent c. So percent d is for integer and percent c is for character. So first ch is integer and second is character. What output do you expect from this program? Possibly 291 and character corresponding to it. Well, not really surprised. So this output of this program is different. So we thought output of program will be 128, but we forgot that a char cannot define take value bigger than 127. So reason is that char ch has been defined as char and char cannot take value bigger than plus 127. Hence when a value of ch exceeds plus 127, an appropriate value from the other side of range is picked up. So appropriate value from other side is picked up and stored in ch. So this value in our case happens to be 35, so any random value is picked. So in our case compiler picked 35, hence 35, and its correspondence character hash gets printed out. So its corresponding character hash gets printed out. Here is another program that would make the concept clearer. So this is program for understanding characters. So here is another program that would make concept of character clearer. Main char char ch, that is ch is equal to character. For ch is equal to 0, ch is less than or equal to 255 ch plus plus. So here we are applying for loop. Ch is equal to 0 means initializing ch. Now ch is less than or equal to 255, that is comparing here. Now ch plus plus, that means we are increasing value of ch. Printf slash n percent d, slash n is for going into next line. Now percent d is for integer value, that is ch is an integer value. Now percent c defines that character, that means ch is a character. Now this program should output ASCII values and their corresponding characters. So we are assuming that output of this program should be ASCII values and their corresponding characters. Well, no, so output is different here. This is an indefinite loop. The reason is that ch has been defined as char and char cannot take values bigger than 1 plus 127. So char is a character and it cannot take values which are bigger than plus 127. Hence when value of ch is plus 127 and we perform ch plus plus, it becomes minus 128 instead of plus 128. So here we are again in the limitations of character and the limitations of its range. So this program's output is different now. Minus 28 is less than 255, hence condition is still satisfied. Here onwards ch would take values minus 127, 126, 125 up to minus 2, minus 1, 0, 1, 2 up to plus 127. etc. Thus, the value of CH would keep oscillating between -128 to +127. So, this value is oscillating, that means it is ranging between -128 to +127. Would declaring CH as an unsigned char solve the problem? Even this would not serve the purpose since CH reaches a value 255. CH++ would try to make it 256. So it is maximum value is 255. CH++ would try to make it 256, which cannot be stored in an unsigned char. So 256 cannot be stored in an unsigned char. Thus the only alternative is to declare ch as an int. So एक alternate, there is one alternative that declares ch as an int. However, if we are bent upon writing the program using unsigned char, main unsigned char ch for ch 254 ch plus plus printf slash n %d %c ch slash n %d %c ch. So this is another program for char. Floats and doubles. A float occupies 4 bytes in memory and can range from minus 3.4 E38 to plus 3.4 E38. So float is occupying 4 bytes in a memory and it is ranging from this. If this is insufficient, then C offers a double data type that occupies 8 bytes in memory. So double data type occupies 8 bytes in memory and has a range from minus 1.7 E308 to plus 1.7 E308. A variable of type double can be declared as double A population. So double A comma population. So double has a range of minus 3.4 E38. A variable of type double can be declared as double A comma population. If the situation demands usage of real numbers that lie even beyond range offered by double data type. So there are some situations in double use while using double data double keyword that if situation demands usage of real numbers that lie even beyond the range offered by double data. So these numbers lie even beyond the range offered by double data double data type, then there exists a long double. So after double data also, beyond that range also we have long double that can range from minus 1.7 E4932 to plus 1.7 E4932. So long double can range from between this range. A long double occupies 10 bytes in memory. A long double is occupying 10 bytes in memory. You would see that most of the times in C programming, one is required to use either char or int, and cases where floats double or long doubles would be used are indeed rare. So there are some cases. So this is table for data types, range and format. So first is sign char. Its range is minus 128 to plus 127 and format is used as %c. Now unsigned char. Its range is from 0 to 255 and format is used as %c. Now short signed integer. Range is minus 32768 to plus 32767 and format is used as %d. Now short unsigned integer. Range is from 0 to 65535 and format is %u. Now signed integer. Range is from 0 to 65535 and format is %u. Now long signed integer. Range is from 21 minus 21 47 48 36 48 2 plus 21 47 48 36 37, and format is percent %ld. Now long unsigned integer ranges from 0 to 429 496 729 5, and format is percent %lu. Now data type is float, ranges from minus 3.4 e 382 plus 3.4 e 38, format is percent %f. Now double, ranges minus 1.7 e 308 2 plus 1.7 e 308, format is percent %lf. Now long double, ranges minus 1.7 e 4932 2 plus 1.7 e 4932, and format is percent capital L F. So this is a table for all the data types range. A few more issues. Having seen all the variations of the primary types, let us take a look at some more related issues. A. We saw earlier that size of an integer is compiler dependent. This is even true in chars and floats. Also, depending upon the microprocessor for which the compiler targets its code, the accuracy of floating point calculations may change. For example, the result of 22.0 divided by 7.0 would be reported more accurately by VC++ compiler. So, result of this float, that is 22.0 divided by 7.0, is reported more accurately by Visual C++ compiler as compared to Turbo C++ compiler. So Visual C++ compiler is more accurate. This is because Turbo C++ targets its compile code to 8088 8086, that is 16-bit microprocessors. So this Turbo C++ compiler, it targets its code to 8088 and 8086 microprocessors. Since these microprocessors do not offer floating point support, Turbo C or Turbo C++ performs all float operations using a software piece called floating point emulator. So floating point emulator is used for performing all float operations. This emulator has limitations and hence produces less accurate results. Also, this emulator becomes a part of exe file, thereby increasing its size. So this emulator become part of exe file, thereby increasing its size. In addition to the increased size, there is a performance penalty, since this bigger code would take more time to execute. So bigger codes take more time to execute. If we look at ranges of chars and ints, there seems to be one extra number on negative side. So if you look at ranges of chars and ints, there seems one extra number on negative side. This is because a negative number is always stored as 2's complement of binary. For example, let us see how minus 128 is stored. Firstly, binary of 128 is calculated. So which is 100 0 0 0 0 0. Then its ones complement is obtained, that is 0 1 1 1 1 1 1 1. A ones complement is obtained by changing all zeros to ones and ones to zeros. Finally, 2's complement of this number, that is 1 0 0 0 0 0 0, gets stored. A 2's complement is obtained by adding 1 to 1's complement. Thus for minus 128, 1 0 0 0 0 0 0 gets stored. This is an 8-bit number and it can be easily accommodated in char. As against this plus 128 cannot be stored in char because its binary 0 1 1 0 1
000000, leftmost zeros is for positive sign, is 9-bit number. However, plus 127 can be stored as binary, turns out to be 8-bit number. So plus 127 is a 8-bit number and this was 9-bit number. Now see storage classes in C. So we are discussing about storage classes. We have already said that all that needs to be said about constants, but we are not finished with variables, so we should know variables also. To fully define a variable, one needs to mentor not only its type. So a fully define a variable, one needs one needs to mention not only its type but also its storage class. So we also have to define its storage class also. In other words, not only do all variables have a data type, so not only do all variables have data type, that means all variables have data types, but they also have storage class. So all variables have storage class also and data type also. We have not mentioned storage classes yet, though we have written several programs in C. So we have not mentioned storage classes, but yet though we have written several programs in C. If we don't specify the storage class of a variable, so if we are not specifying storage class in a variable, in its declaration the compiler will assume a storage class depending on context in which variable is used. So the storage class of compiler will declare or assume a storage class depending on context in which variable is used. From C compiler's point of view, a variable name identifies some physical location within the computer. So from C compiler's point of view, a variable name identifies some physical location within the computer where the string of bits representing a variable value stored. So if we think like C compilers, that means if we go through C compiler's point of view, a variable name identifies some physical location. So it has some ASCII code or a number. So it locates or it tells some identifies some physical location within the computer where the string of bits representing a variable value stored, and in that location a string of bit representing a variable value stored. There are basically two kinds of locations. So there are two kinds of locations in a computer where such a value may be kept. So there are two kinds of location. So memory and CPU registers are two kind of locations. It is the variable storage class that determines in which of these two locations value is stored. That means it is variables storage class. So variable storage class is defining or determining in which of these two locations the value is stored. Moreover, a variables storage class tells us A, where the variables would be stored. So variable storage class tells us that where the variables would be stored. So this is A. Now B, what will be the initial value of variable. So variable storage class tells us that what will be the initial value of variable. Now if initial value is not specifically assigned, so if initial value is not specifically assigned, that is default initial value, so what will be the uh, initial value then? So if it is not assigned like 0, so what will be, so it defines that. Now what is scope of the variable, that is in which functions the value of variable would be available. So what is scope of variable? Now D, what is life of variables, that is example how long would be variable exist, that means long, short, etc. So that is D. There are four storage classes in C. A. Automatic storage class. B. Register storage class. C. Static storage class. D. External storage class. So these are storage types of storage classes in C. Let us examine these storage classes one by one. First is automatic storage class. Automatic storage class. The features of variable defined to have an automatic storage class are as under: storage memory, default initial value, and unpredictable value, which often called a garbage value. So default initial value is garbage value. Scope local to the block in which the variable is defined. Now life till the control is defined, till the control remains within the block in which variable is defined. So these are properties of automatic storage class. Now example program. Following program shows how an automatic storage class variable is declared. Main auto int I comma j, printf slash n percent d I comma j. The output of above program could be 1211 221, where 1211 and 221 are garbage values of I and j. Since garbage values are unpredictable, so always make it 0. Point that you initialize the automatic variables properly. So always initialize it to an automatic variable, otherwise you are likely to get unexpected results. So otherwise you can get unexpected results. Note that the keyword for this storage class is auto and not automatic. So variable for this storage class is auto and not automatic. Scope and life of an automatic variable is illustrated in following program. First is main, which is a compulsory function. Now auto int I is equal to 1. So I is an integer which is automatic variable and which is equal to 1. Now printf n, that is on next line, percent d comma I. So I is an integer, percent d comma I. Now printf percent d comma I, printf percent d comma I. The output of above program is 111. This is because all printf statements occur within the outermost block. A block is all statements enclosed within pair of bases. So this is because printf statements occur within outermost block in which I has been defined. It means the scope of I is local to the block in which it is defined the moment the control comes out of the block in which variable is defined. So it means the scope of I is local to the block in which it is defined. So moment the control comes out of the block in which variable is defined. Now we will see another program. Main, this is compulsory function. Auto int I is equal to 1. So I is an integer which is equal to 1. Auto int I is equal to 2. So 2 is an integer which is auto. So which comes under auto keyword. Now auto int I is equal to 3. Printf slash n percent d comma I. So percent d is for integer value and I is an integer. Printf percent d comma I, printf percent d comma I. The output of above program would be 3 to 1. Note that the compiler treats the three i's as totally different variables. So compiler is treating three i's as totally different variables since they are defined in different blocks. So they are defined in different blocks. Now once the control comes out of innermost block, once the variable I with the value 3 is lost, and hence the I in the second printf refers to I with the value 2. Similarly, when the control comes out of next innermost block, the third printf refers to I with value 1. Understand the concept of life and scope of an automatic storage class variable thoroughly before proceeding to next storage class. So automatic storage class is important in C. Register storage class. The features of variable defined to be register storage class are as under. So register storage class has some features. First, storage, CPU registers, default initial value, garbage value. that means it is a random value, that is garbage value. Now scope, local to block in which variable is defined. So it is used in a block in which variable is defined. Life, till control remains within block in which variable is defined. So it works within the block in which variable is defined. A value stored in a CPU register can always be accessed faster than one that is stored in memory. So a value which is stored in CPU register is accessed faster than which is stored in a memory. Therefore, if a variable is used at many places in program, it is better to declare its storage class. So if one variable is used many times in a program, so it is better to declare its storage class as register A. So declaring first storage class is is better. A good example of frequently used variable is loop counters. So loop counters is frequently used. We can name their storage class as register. So loop counters are frequently used. Now example, main register int. So this is a sample program. Register int I for I is equal to 1, I is less than equal to 10, I plus plus, printf slash n percent d comma I. So percent d is used for here, even though we have declared the storage class of I. So as a integer, register integer, we have declared storage class of I as register. We cannot say for sure that value of I would be stored in a CPU register. So we are not sure here that we have declared it as a register, but we are not sure that it will be actually stored in CPU register. But why? Because the number of CPU registers are limited. So numbers are limited, CPU registers are limited, and they may be busy doing some other task. So number of CPU registers are limited and they are busy doing some other task. What happens in such an event? The variable works as if its storage class is auto. So variable is working as its storage class is auto. Not every type of variable can be stored in a CPU register. For example, if the microprocessor has 16-bit registers, then they cannot hold a float value or double value, which requires 4 and 8 bytes respectively. So float and double values are requiring 4 and 8 bytes respectively. However, if you use register storage class for float or a double, so for however if you are using register storage class for a float or a double variable, you won't get any error messages. All that would happen is the compiler would treat the variable to be auto storage class. So compiler is treating variables as auto storage class. Static storage class. The features of a variable defined to have a static storage class are as under. So these are features which are useful for defining static storage class. First is storage, that is memory. So it is stored in memory, that's why storage is there. Now default initial value is 0. So in the case of other storage classes we had garbage value which was a random value, but here it is default initial value, that is here it is 0, it is defined. Now scope, local to black in which variable is defined. So scope is local to block in which variable is defined. Now life, value of the variable purchased between different function calls. So it is between function calls, so that is life. Compare two programs and outputs in the following figure to understand the difference between automatic and static storage class. So these are programs which look similar but their output is different. So first program is main, then increment, so these are three functions. There is one function which is written three times. Now in increment function, auto int I is equal to 1, printf slash n comma I, then I is equal to I plus 1. So output of the program is 1 1 1. So that means this is output of first program. Now let's see second program, main increment increment increment. Now in increment function, static int I is equal to 1, printf percent d comma n comma I is equal to I plus 1. So output of this program is 1 2 3. Now we will see explanation how these outputs are coming different. The programs above consist of two functions, main and increment. The function increment gets called from main thrice each time it increments the value of I and prints it. So it consists two functions, that is main and increment. The function increment is getting called when from main thrice. So function is getting called from main function, so it is inside main function. Each time it increments the value of I and prints it. The only difference in two programs is one uses auto storage class and for variable I, whereas the other uses static storage class. First one was using auto class, second is using static storage class. Like auto variables, static variables are also local to block in which they are declared. So static variables are also local to block in which they are declared. The difference between them is that static variables don't disappear when function is no longer active. So static variables don't disappear when function is no longer active. Their values persist. If the control comes back to same function again, the static variables have the same values they hold last time around. So static variables have they are holding same values which they had last time. In the above example, when variable I is auto, each time increment is called, it is reinitialized to 1. When the function terminates I, vanishes and its new value is of 2 is lost. That means the result is no matter how many times we call increment, I is initialized to 1 every time. So no matter how many times we call increment, I is initialized to 1. On other hand, if I is static, it is initialized to 1 only once. It is never initialized again. During the first call to increment, I is increment to 2. Because I is the static, this value persists. The next time increment is called, I is not reinitialized to 1. On the contrary, the old value 2 is still available. This current value of I, that is 2, gets printed, and then I is equal to I plus 1 adds 1 to I, get a value of 3. Now when increment function is called the third time, the current value of I, that is 3, gets printed, and once again I is incremented. In short, if the storage class is static, then statement static int I is equal to 1 is executed only once, irrespective of how many times the same function is called. Consider one more program, main int star I. So main is a compulsory function. Now int star I. So address of int star j, address of j, that means. Now int star fun, address of fun function. Now j is equal to fun, that is function. Printf slash n percent d comma star j, that is address of j. Slash n is written for going to next line. Now int star function, int k is equal to 35, return ampersand k. Here we are returning an address of k from function, that is fun, and collecting it in j, thus j becomes pointer to k. Then using this pointer we are printing value of k. Then using this pointer we are This correctly prints out as 35. So value of k is 35. So this is correctly being printed out as 35. Now try calling any function, even printf, immediately after the call to function. This time printf prints a garbage value. So this time printf is printing a random value. Why does this happen? In first case, when the control returned from that is function fun through k went dead, it was still left on stack. We then accessed this value using its address that was collected in J. But when we precede the call to printf by a call to any other function, the stack is now changed. Hence we get a garbage value, that is random value. If we want to get a correct value each time, then we must declare k as a static. By doing this, when control returns from function fun, k would not die. All this have been said. A word of advice. So there is a word of advice, that is, avoid using static variables unless you really need them. Because so you can avoid using static variables also, because their values are kept in memory when variables are not active. So values of static variables are kept in memory when variables are not active, which means they take up space in memory. So they take space in memory that could otherwise be used as other variables. So use static variables only if you need them, really, if you really need them. External storage class. The features of a variable whose storage class has been defined as external are as follows. Features of this class are: storage memory, default initial value 0, scope global, life as long as program's execution doesn't come to an end. External variables differ from those we have already discussed in that their scope is global, not local. External variable are declared outside all functions. Int I, so I is an integer. Now main, here the main function starts. Printf slash n I is equal to %d comma I. So I is an integer, so it was declared. Now increment, now decrement. So increment is one function and decrement is another function. Now increment I is equal to I plus 1. Printf slash n non-incrementing I is equal to %d comma I. Decrement I is equal to I minus 1. Printf slash n non-decrementing I is equal to %d comma I. So output of this program would be I is equal to 0. On incrementing I is equal to 1. On incrementing I is equal to 2. On decrementing I is equal to 1. On decrementing I is equal to 0. As is obvious from the above output, the value of I is available to the functions increment and decrement, since I has been declared outside all functions. Look at following program. Int x equal to 21 main extern int y, printf slash n %d x comma y. Int y is equal to 31. Here x and y both are global variables. Since both of them have been defined outside all functions, both enjoy external storage class. Note the difference between the following. Extern int y is equal to 31. Here the first statement is a declaration, whereas the second statement is definition. So this is a program for external storage class. Another small issue: what will be the output of the following program? Int x is equal to 10 main, int x is equal to 20, printf slash n %d comma x. Display, so display is a function. Now display printf slash n %d comma x. Here x is defined at two places, once outside main and once inside it. When the control reaches the printf in main, which x gets printed. Whenever such a conflict arises, it's a local variable that gets preference. So over global variable. So local variable is first preferred over global variable. Hence printf outputs 20. So here local variable is getting preference. When display is called and control reaches the printf, there is no such conflict. Hence this time the value of global x, that is 10, gets printed. One last thing, a static variable can also be declared outside all the functions. So it can be declared outside the functions also. For all practical purposes, it will be treated as an external variable. So it will be treated as an external variable. This means that the variable would not be available to any function that is defined in a file other than the file in which the variable is defined. Which function to use when? We can make a few ground rules for usage of different storage classes in different programming situations with a view to a. Economize the memory space consumed by variables. So first we have to economize the memory space. Now second P is improve the speed of execution of program. The rules are as under: use static storage class only if you want the value of a variable to persist between different function calls. Use register storage class for only those variables that are being used very often in a program. Reason is that there are very few CPU registers at our disposal and many of them might be busy doing something else. So many of the CPU registers might be busy doing something else. A typical application of register storage class is loop counters, which get used a number of times in a program. So loop counter is getting used a lot of times in a program. Use external storage class for those variables that are being used by almost all the functions in the program. This would avoid unnecessary passing of these variables as arguments when making a function call. Declaring all the variables as external would amount a lot of wastage of memory space because these variables would remain active throughout the life of a program. If you don't have any of the express needs mentioned above, then use the auto storage class. So we can use also auto storage class. In fact, most of the times we end up using the auto variables because often it so happens that once we have used the variables in a function, we don't mind losing them. Chapter 7: The C preprocessor. The C preprocessor is exactly what its name implies. It is a program that processes our source program before it is passed to compiler. So it is a basically source program processor. That means it is a source program processor. Before our program is passed to compiler, it processes our program. But preprocessor is such a great convenience that virtually all C programmers rely on it. So all C programmers rely on it. Now features of C preprocessor. There are several steps involved from stage of writing a C program to stage of getting executed. So there are several steps involved in writing a C program and up to it getting executed. You can observe from figure that our program passes through several processors before it is ready to be executed. So you can observe from figure that, so we will see a figure in which our program passes through several processes before it is ready to be executed. Note that if the source code is stored in a file pr1.c, then the expanded source code gets stored in file pr1.i. When this expanded source code is compiled through object code, it gets stored as pr1.obj. So first it is pr1.c, now it is pr1.i, and finally it is pr1.obj. When this object code is linked with object code of library functions, the resultant executable code gets stored in pr1.exe. So finally it is turned into pr1.exe. First it was pr1.c, now it is pr1.i, then it is pr1.obj, and finally it is pr1.exe. The preprocessor offers several features called preprocessor directives. Each of these preprocessor directives begin with a hash symbol. The directives can be placed anywhere in program but are most often placed at beginning of a program. Before first function definition, we would learn the following preprocessor directives here. A is macro expansion, B is file inclusion, C is conditional compilation, D is miscellaneous directives. So this is a figure in which we get flow of program. First it is handwritten program, then it is stored in text editor or a text editor software, that is Notepad, WordPad, etc. is used for a handwritten program. Now C source code pr1.c, then it is turned into C source code as pr1.c. Now it goes to preprocessor, then after preprocessor it goes for expanded source code, that is pr1.i, then it goes to compiler and we get object code, that is pr1.obj, and finally it gets to linker, and finally we get executable code, that is pr1.exe. So these are functions of different programs. First is editor. So input is program type from keyboard and output is C source code containing program and preprocessor commands. So editor's output is C source code containing program and preprocessor commands. Now preprocessor's input is C source code file and output is source code file with preprocessing commands which are properly sorted out. So preprocessor commands are properly sorted out here. Compiler source code file with preprocessing commands sorted out. So relocatable object code is output. Linker. So linker is relocatable object code and the standard C library functions. So that is input. Now output is executable code in machine language. This is output. Macro expansion. So this is a program which is explaining macro expansion. Hash define upper 25 main int I. So I is an integer. Now for loop, for I is equal to 1 semicolon, I is less than or equal to upper, then semicolon I plus plus, printf slash n percent d comma I. So slash n is written for a writing in next line. In this program, instead of writing 25 in the for loop, we are writing it in upper, which has already been defined before main through this statement. Hash define upper 25. This statement is called macro definition or more commonly a macro. So hash define upper 25. So these such kind of statements are called macro definition or simply they are called as macro. Here is another example of macro definition. So hash define pi is equal to 3.1415. Main float r is equal to 6.25 float area. So float is r, which is 6.25. Now float area, so area is also a float. Area is equal to pi star, that is multiplied by r star r. Printf slash n area of circle is equal to percent %f comma area. Upper and pi in above programs are often called macro templates, whereas 25 and 3.1415 are called their corresponding macro expansions. When we compile the program, before the source code passes to compiler, it is examined by C preprocessor. So before passing it to compiler, it is examined by the C preprocessor for any macro definitions. In C programming, it is a customary to use capital letters for macro template. This makes it easy for programmers to pick out all the macro templates when reading through the program. Note that a macro template and its macro expansions are separated by blanks or tabs. A space between hash and define is optional. Remember that a macro definition is never to be terminated by a semicolon. So we cannot terminate a macro definition by semicolon. And now $1 million question. Why use hash define in the above programs? So this is a very interesting question, that why we are using hash define in the above programs. What we gain by substituting pi for 3.14 in our program, and there are so many such instances where a constant doesn't reveal its purpose so readily. For example, if the phrase uh, slash x1b2 causes the screen to clear, but which would you find easier to understand in middle of your program slash x 1b 2j or clear screen. Thus we would use the macro definition hash define clear screen. So using this code uh, is difficult than using define hash define clear screen. Whenever the clear screen appears in program, it would automatically be replaced by this number, that is slash x 1b 2j before compilation begins. So writing hashtag define clear screen, so this is easy as compared to writing its code. So that is why hash define directive is important, and it is frequently used in programs. However, if you have defined pi in a hash define directive, you only need to make one change in the hash define directive itself. Hash define pi 1. 3.141592. So we can also define pi in hash define directive. So by using this statement hash define pi 3.141592, we can do that. In short, it is nice to know that you would be able to change values of a constant at all places in the program by just making a change in the hash define directive. So by making changes in hash define directive, you can change values of constants. But the same purpose could have been served had we used a variable pi instead of macro template pi. A variable could also have provided a meaningful name for a constant and permitted one change to effect many occurrences of constant. Firstly, it is inefficient since the compiler can generate faster and more compact code for constants than it can for variable. So compiler can generate faster and more compact code for constants. Secondly, using a variable for what is really constant encourages sloppy thinking and makes program more difficult to understand. So using a variable for what is really a constant, it encourages a sloppy thinking and makes program easy to understand. If something never changes, it is hard to imagine it is a variable, and thirdly, there is always a danger that the variable may inadvertently get altered somewhere in the program. That means if something never changes, it is hard to imagine it is variable, and thirdly, it is always danger that variable may inadvertently get altered somewhere. So variable get can get altered somewhere in the program, so it's no longer constant that you think it is. Thus using hash define can produce more efficient and more easily understandable programs. So using of hash define directive is efficient and useful in programs. A hash define directive is many a times used to define operators as shown below. Hash define and now hash define uh, or. So this is an example program in which this hash define directive is used. Now main int f is equal to 1. Now x is equal to 4, y is equal to 90. If f is less than 5 and x is less than or equal to 20, or y is less than or equal to 45, printf /n your pc will always work fine. Else printf /n in front of the maintenance man. A hash defined directive could be used even to replace a condition as shown below. Hash define and hash define arrange a is more than 25 and a is less than 50. Main int a is equal to 30. If arrange printf within range, else print out of range. A hash defined directive could be used to replace even an entire C statement. This is shown below. Hash defined found printf your the Yankee Doodle virus. Main uh, char signature, if signature is equal to y, found, else printf safe as yet. Macros with arguments. The macros that we have used so far are called simple macros. Macros can have arguments just as functions. Here is an example that illustrates this fact. So macros are similar to functions. They can also have arguments like functions. Hash define area x 3.14 star x star x. So this is a macro called area. Now main float r1 is equal to 6.25, r2 is equal to 2.5, comma a. So a is also float. Now a is equal to area r1. Printf /n area of circle is equal to %f comma a. A is equal to area r2. Printf /n area of circle is equal to %f comma a. So here is output of program. Area of circle is equal to 122.656250 and area of circle is equal to 19.625000. In this program, wherever the preprocessor finds the phrase area, it expands it into statement 3.14 star x star x. The statement area r1 in the program causes the variable r1 to be substituted for x. Thus the statement area r1 is equivalent to 3.14 star r1 star r1. After the above source code has passed through the preprocessor, what the compiler gets to work on will be this. Main float r1 is equal to 6.25, r2 is equal to 2.5, a is equal to 3.14 star r1 star r1. So here we are getting that r1 r2 and a are float. Now a is equal to 3.14 star r1 star r1. Printf area of circle is equal to percent f slash n comma a. Now a is equal to 3.14 star r2 star r2. Printf area of circle is equal to percent f comma a. Here is another example of macros with arguments. Hash define is digit y, then y is greater than 48 and y is greater than or equal to 57. Main char ch printf enter any digit, scanf percent %c comma ampersand ch if is digit ch. Printf on next line you entered a digit, else printf slash n illegal input. So this is another example of macro. Be careful not to leave a blank between macro template and its argument while defining the macro. For example, there should be no blank between area and x in the definition. Hash define area x 3.14 star x. If we were to write area x instead of area x, the in bracket x would become part of macro expansion, which we certainly don't want. So what would happen is the template would be expanded to r1 3.14 star r1, which won't run, not at all what we wanted. The entire macro expansion should be enclosed within the parenthesis. Here is an example of what would happen if we fail to enclose the macro expansion within parenthesis. So macro expansion should be enclosed within parenthesis. So this is an example in which macro expansion is not if macro expansion is not included within parenthesis, then what will happen? Hash define square in bracket n star n main int j is equal to 64 divided by square 4. Printf j is equal to percent %d comma j. The output of above program would be j is equal to 64. Whereas what we expected was j is equal to 4. What went wrong? The macro was expanded into j is equal to 64 divided by 4 into 4, which yielded 64. So we cannot do that. That means it should not be out of parenthesis, it should be in parenthesis. Macros can be split into multiple lines with a backslash present at end of each line. So they are split into multiple lines also with help of a backslash. So example, hash define edge line for I is equal to 0, I is less than 79, I plus plus. Printf percent %c comma 196. Hash define v line xy slash backslash 90. Go to xy x comma y. Printf uh, percent %c 179. Now main. So main is in main function we are writing integer I y. So I and y are integer. Now clear screen. Go to xy 1 comma 12 edge line for y is equal to 1, y is less than 25, y plus plus v line 39 comma y. So this is a program for drawing vertical and horizontal lines on screen. If for any reason you are unable to debug a macro, then you should view the expanded code of the program to see how the macros are getting expanded. So if you are unable to debug a macro, then you should view expanded code of program. If your source code is present in the file pr1.c, then the expanded source code would be stored in pr1.i. You need to generate this file at the command prompt by saying cpp pr1.c. Here CPP stands for C preprocessor. It generates the expanded source code and stores it in the file called pr1.i. Note that the file pr1.i gets generated in c/tc/bin directory. So this file is stored in a certain directory by default. Now macros versus functions. In a macro call, the preprocessor replaces the macro template with its macro expansion in a stupid, unthinking, literal way. As against this, in a function call, the control is passed to a function. So, against this, in a function call, the control is passed through a function. This brings us to a question when it is best to use macros with arguments and when it is better to use as a function. Usually macros make the program run faster but increases program size, whereas functions make program smaller and compact. So macros makes program run faster and increases program size, but the functions make program smaller and compact. If we use a macro 100 times in a program, the macro expansion goes into our source code at 100 different places. So the macro expansion goes in our source code at 100 different places if we are using macro 100 times. The moral of the story is if uh, if the macro is simple and sweet like in our example, it makes nice shorthand and avoids the overheads associated with function calls. So if macro is simple and sweet, then uh, then it avoids overhead associated with function calls. File inclusion. The second preprocessor directive we will explore in this chapter is file inclusion. The preprocessor command for file inclusion looks like this: hash include file name, and it simply causes the entire contents of file name to be inserted into source code at point in program. When and why this feature is used, it can be used in two cases. So use of or need of this file inclusion feature is as follows. If we have a very large program, the code is best divided into several different files, each containing a set of related functions. So if we have a large program, then code is divided into different files, each containing set of related functions. It is a good programming practice to keep different sections of large programs separate. These files are hash included at beginning of main program file. There are some functions and macro definitions that we need almost in all programs that we write. So there are some functions and macro definitions that we are using everywhere. These commonly needed functions and macro definitions can be stored in a file, and that file can be included in every program we write, which would add all statements in file to our program as we have typed them in. It is common for the files that have to be included to have a .hex extension. So .hex extension is common. This extension stands for header file. So .h means header file, possibly because it contains statement which when included go to head of your program. So it contains statement which when included goes to head of your program. That means it is a header file. For example, prototypes of all mathematics related functions are stored in header file math.hex. prototypes of console input output functions are stored in header file conio.hex. So math.hex and conio.hex are two header files. So if we want to use power function, that means 2 raised to 2, so we cannot use directly in any program. So for that we have to define that include #include math.hex. So some functions are also stored in conio.hex also. Actually there exist two ways to write #include statement. These are #include file name, #include in bracket file name. The meaning of each of these forms is given below. #include goto.c. This command would look for the file goto.c in the current directory as well as in the specified list of directories as mentioned in include search path that might have been set up. Now #include goto.c. This command would look for the file goto.c in specified list of directories only. The include search path is nothing but a list of directories that would be searched for file being included. So the include search path is nothing but a list of directories that would be searched for the file being included. Different C compilers let you set the search path in different manners. So different compilers are storing that data in different paths. If you are using Turbo C C++ compiler, then the search path can be set up by selecting directories from options menu. So if you are using Turbo C++ or C, then they have we can directly go to directories from option menu, or we can also specify multiple include paths separated by semicolon as shown below. C /tc lib c /mylib d /lib files. So we can also specify like this also. The path that contains maximum of 127 characters, both relative and absolute path are valid. For example, dir /inc files is a valid path. Conditional compilation. So this is example of conditional compilation. #if def macro name statement 1 statement 2 statement 3 #endif. So this is example of conditional compilation. If macro name has been hash defined, the block of code will be processed as usual, otherwise not. To comment out obsolete lines of code, it often happens that a program is changed at last minute to satisfy a client. So sometimes program is changed at last minute. This involves rewriting some path of source code to client satisfaction and deleting the old code. So we delete some old code and we change code. One solution in such a situation is to put the old code within the this pair of star then slash star combination. But we might have already written a comment in the code that we are about to comment out. This would mean we end up with a nested comment. Obviously this solution won't work since we can't nest comments in C. Therefore the solution is to use conditional compilation as shown below. Main #if def OK statement 1 statement 2. So statement 2 then comment is it detects virus. Statement 3 statement 4 specific specific to stone virus. Endif statement 5 statement 6 statement 7. Here statements 1 2 3 and 4 would get compiled only if the macro OK has been defined and we have purposefully omitted the definition of macro OK. At a later date, if we want that these statements should also get compiled, all that we are required to do is to delete the hash if def and end if statements. B. A more sophisticated use of hash if def has to do with making the programs portable, that is to make them work on two totally different computers. So this is also use of hash if def. You can do so by isolating the lines of code that must be different for each machine by marking them off with hash if def. For example, main hash if def intel code sustainable for Intel PC, hash else code sustainable for a Motorola PC, hash end if code common to both computers. When you compile this program, it would compile only the code sustainable for Intel PC and common code. This is because the macro Intel has not been defined. Note that the working of hash if def, hash else, hash end if is similar to ordinary if else control instructions of C. If you want to run your program on a Motorola PC, just add a statement at top saying hash define Intel. Sometimes for a Motorola PC we can use these statements. Sometime instead of hash if def, the hash if and def directive is used. The if and def, which means if not defined, works exactly opposite to hash if def. The above example, if written using hash if and def, would look like this: main hash if and def Intel code suitable for a Intel PC, else hash else code suitable for a Motorola PC, hash and if code common to both computers. Suppose a function myfunc is defined in a file myfile.x. So myfunc is defined in myfile.x, which is hash included in a file myfile1.x. So it is included in this file. Now in your program file, if you hash include both myfile.x and myfile1.x, the compiler flashes an error multiple declaration for myfunc. Myfile.x hash if and diff slash myfile slash h hash define slash myfile slash h myfunc some code bracket complete and hash and if. First time the file myfile.x gets included, the preprocessor checks whether a macro called myfile.x has been defined or not. So first when it gets included, the preprocessor is checking that is that file is included or not. Next time we attempt to include the same file, the inclusion is prevented since myfile hex already stands defined. Note that there is nothing special about myfile hex. In this place we can use any other macro as well. So we can use any other macro as well. If and elif directives. The hash if directive can be used to test whether an expression evaluates to a non-zero value or not. So hash if directive is used for testing is it 0 or not 0. If the result of expression is non-zero, then the subsequent lines up to a hash else or a hash elif or a hash end if are compiled, otherwise they are skipped. A simple example of hash if directive is shown below. Main hash if test is less than or equal to 5, statement 1, statement 2, statement 3, hash else, statement 4, statement 5, statement 6, hash and if the expression test is more than or equal to 5 evaluates to true, then statements 1, 2 and 3 are compiled, otherwise statements 4, 5 and 6 are compiled. In place of the expression test is less than or equal to 5, other expressions like level is equal to high, or level is equal to low, or adapter is equal to CGA can also be used. So these are also expressions which can also be used. Now example, hash if adapter is equal to VGA, code for video graphics array, else hash if adapter is equal to SVGA, this is code for super video graphics array, hash else code for extended graphics adapter, hash end if. The above program segment can be made more compact by using another conditional compilation directive called hash elif. The same program using this directive can be rewritten as shown below. Observe that using hash elif directives, the number of hash and if used in program gets reduced. Hash if adapter is equal to VGA, code for video graphics array, else if adapter is equal to SVGA, this is code for super video graphics array, hash else code for extended graphics adapter, hash and if. Miscellaneous directives. There are two more preprocessor directives available through though they are not commonly used. They are hash undiff and hash pragma. So these are two directives. So pragma is very rarely used and undiff is also very rarely used. So let us first discuss about undiff directive. On some occasions, it may be desirable to cause a defined name to become undefined. This can be accomplished by means of the undef directives. In order to undefine a macro that has been earlier hash defined the directive, so sometimes it may be desirable to uh, cause defined name to become undefined. So there this directive is used. So it is used for undefine a macro that has been earlier defined in the directive. So we have to sometimes we have to undefine it. For undefining, this undef directive is used. Hash undef macro template can be used. Thus the statement hash undef Pentium would cause the definition of Pentium to be removed from the system. So all subsequent hash if def Pentium statements would evaluate to false. In practice, seldom are you required to undefine a macro, but for some reason, if you are required to do, then you know that there is something to fall back upon. Hash pragma directive. This directive is another special purpose directive that you can use to turn on or off certain features. So this is used for turning on or off certain features. So this is used for actually we can use assembly language also with this directive. So in C language we can also use assembly language with the help of this directive. Programs vary from one compiler to another. There are certain pragmas available with